Assalamualaikum warahmatullahi wabarakatuh. Shalom, Om Swastiastu, Namo Buddhaya, Salam Kebajikan. Ladies and gentlemen, distinguished guests, and honored participants, good morning.
Welcome back to today's event, International Conference on Ship and Offshore Technology 2023 with the theme Ship Safety and Energy Efficiency with me Happy and my partner
Faiz, as your master of ceremony. Yesterday, we have witnessed several presentations and discussion from the presenter, and we are very grateful for the knowledge that has been shared, which can add to our insight and also inspire the audience here.
We will continue yesterday's presentation and discussion, which will include several presenters, and we will give to the moderator, Dr. Insinyur Fajri Asviraihan, STMT.
Good morning, everyone. Assalamualaikum warahmatullahi wabarakatuh. Shalom, Om Swastiastu, Namo Buddhaya, Salam Kebajikan. Introduce my name, Dr. Fajri, as as moderator, and I will read the rules presentation of presenter. The presenter will have only 10 minutes for their presentation, and then at least 5 minutes to question and answer session. Okay, for the next presenter is the first presenter is Muhammad Ridwan Utina with paper title Hydrodynamic Analysis on X-bow and Conventional bow shape for radashing resistant using CFD simulation. Is there Mr. Muhammad Ridwan Utina?
Yes, I'm here.
Okay, please share your screen, Mr. Utina.
Okay. Is there the
Yes.
okay.
You can start.
Yeah, thank you. First of all, I want to thank you very much to moderator Pak Fajri for giving me opportunity to join this conference and to present my presentation. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Allow me to introduce myself. My name Muhammad Ridwan Utina, and I work at Research Center of Hydrodynamic Technology, which is belong to National Research and Innovation Agency, and the abbreviation is PRIN, as a researcher. And also I'm currently a master degree student at Department Marine Engineering of Institut Teknologi Sepuluh Nopember, located in Surabaya from 2022 until now. My title of presentation is about hydrodynamic analysis on X-bow and conventional bow shape for reducing resistance using CFD simulation. The background of the research study is we know that high-speed vessels such as fast patrol boat need to pay attention to two conditions, namely fuel consumption, which is related to the speed, also related to the resistance, and another is passenger comfort. As we know, the fuel oil costs have been about 60 to 70% of total operational costs explained by ship owners, driving their constant efforts to adopt proven technology that reduce fuel consumption. So increasing pressure of rising cost of fuel also make this to be considered. Another reason is the IMO regulation of energy efficiency index that regulate to control the carbon emission. So that was the background for this study. And the aim of this research study is to perform calm water resistance simulation of two monohulls of fast patrol boat with different bow shape, which is conventional and axial bow shape using CFD simulation. And then to compare the result of total resistance, which has component residual resistance and friction resistance between both shape. And then to analyze what will be the dominant component of resistance that influence of the total resistance. And the last is to predict how much the contribution of resistance reduction using axial. Let me show you. I think this is already familiar with almost of you, of course. A lot of formula I use in this study, resistant and resistant component, which is according to the ITTC 57, also according to the Hughes. For ITTC, the total resistance is subvention of frictional resistance and residual resistance. For Hughes, is total resistance is submission of viscous resistance and also the wave resistance. And also we can illustrate after the last slide in this presentation is the coefficient resistance, which is dimensionless, which is total resistance coefficient and friction coefficient, and also the viscous coefficient. A little bit about the hydrodynamic characteristic of conventional bow and axial bow, which is from the bow shape, you can recognize that the conventional bow shape are typically characterized by pointed V-shape from that slices through the water. This design has been the standard for centuries. While the axial bow have a more distinctive and innovative shape with a sharp and almost horizontal entry, and its look as in the front of the ship has been cut off. And another aspect is wave making resistance. Conventional bow tend to create more pronounced bow waves as they move through the water, leading to higher wave making resistance. While axial bow are designed to reduce wave making resistance, and their distinctive shape helps to mitigate the formation of a large bow wave. Moving to previous research have already been done by a researcher. I use this as a literal reference. A collaboration first is at 2001, which is Koenig, which is come from Delft University with Diamond Company and Marine, which is in Wageningen, developed the actual concept and have conducted a model experiment as fast monohull illustrate remarkable achievement with 30% reduction at required installed power and design speed 25 knots. And also Mossad doing the same research, which is wave making resistance using the axial bow model, and resistance specifically dropped to 29% at float number at low fruit number and at moderate fruit number at 40% and by 6% more when it on the high fruit number, and it seems it becomes lower as the fruit number is increasing. Also, Sutio, this is doing by maybe my colleague also, Professor Ketut, they have conducted the same simulation of NPL model of Trimaran. Yeah, of course, this is different with the monohull, but I just want to show that the effect of using axial wave model can give a minimal wave generation along the hull and hull-to-hull interaction, and it was found that this causes a significant effect on the total resistance, which is result resistance reduction about 26%. And the last is Basil and Waris has observed also the optimal design of the Ullstein axial hull started a remarkable 11% reduction resistance of trolling speed, and this is fishing good. And methodology uses safety simulation because which is used some pieces during a preliminary design. It provides a modern alternative to towing tanks and can test performance digitally using a virtual model in numerical towing tank. And the hydrodynamic simulations are quick to set up and run, so they can develop much earlier in the design process. CFD simulation setup, the computation were performed using CFD, software package Fine Marine, Nomica, and it's implemented to fast patrol boat 60 meter for both conventional bow and axial bow shape, and we do it at calm water condition. And we do it also speed between 20 to 30 knots, which is correspond to fruit number 0.46, 7 and 6.5. And the shape, as I illustrate the figure below, and the dimension about the same, about the same. The length, the LL of course different, and also the breadth is almost the same. And also displacement, of course, we use the same displacement because we have to compare it. And wetted area, it's almost also the same. And so we're doing simulation, and this is the domain and meshing we do according to the ITPC, which is as a function of ship's length. And we check also to determine the correct mesh size, select in the numerical simulation to have optimum time also, but still accurate. So grid independence, we do it several combination of meshing size. So we found it, but we do it about 2.5 million cell. Which is the error is here. And this is the visualization of wave pattern and hydrodynamic pressure at fruit number 0.5 to 5.5. Which is we saw the wave pattern here. Seems conventional and compared to axial, seems the wave pattern lower than conventional bow. And also hydrodynamic pressure here, the red color here, it's more in conventional bow compared to AXABO. And also the result we verified with safety simulation with because fast high-speed vessel, in this case fast patrol boat, it's a slender body. So we compared the slender body, the result of the simulation. And yeah, it's comparable and it's considerable good. And this is the result in table, which is here, total resistance comparing between AXABO and conventional bow, and the reduction percent of reduction resistance is for 2020 knot, it's about 12%, and also and becoming decrease at until 32 knots in 9.5%. And when we compose into resistance of friction resistance, and also here friction resistance and also residual resistance, and we can show that for instance, for 22 knots, the residual resistance reduction is 21%. At 32 knots, reduction on residual resistance is decreased about 17%. But here, in
your presentation still 2 minutes left. Please speed.
Okay.
Everyone.
Okay. Friction resistance is about the same because we know that the wetted surface area is almost the same. And this is another illustration in the graph on the curve of result of resistance. And here is a little bit lower, you see, a little bit seems to be like a hand. And also here, and residual resistance a bit yeah, 30 knots, so a bit lower. But in friction resistance, it is almost the same as I said before. And we saw it in coefficient resistance. So it seems to me the result becoming lower of total coefficient resistance, and seems to me becoming lower, not too linear. And this is caused by if we see the residual coefficient, it's also give another the same 10. So in conclusion, compared with conventional bow, AXABO shape improves ship hydrodynamic performance by contributing a reduction of total resistance between 9.5 to 12%, and the reduction effect of residual resistance on AXABO is about 11%, 18% to 21%, while friction resistance provides a quite similar effect due to both shape have relatively same displacement and wet surface area. And then residual resistance of AXABO has contributed a dominant effect of the total resistance about 50%. And this is normal for the high float number. Speed vessel give the residual resistance give more dominant because normally for cargo vessel, container vessel, or also bulk carrier give less residual resistance. And then the last is further work. I will do it a model test to be carried out and to validate the CFD simulation. So that's all I have my presentation. Moderator, thank you very much.
Thank you, Mr. Ridwan. And if there are any question to Mr. Ridwan, Rico, Rico.
Okay, morning, Cak Ridwan. How are you?
Morning, Mr. Rika, Dr. Rika.
So, interesting topic because you also mentioned EEDI, which is now currently the visions, but
Yeah, look. I cannot hear your voice, Pak Ika.
Test.
Yeah, okay.
Yes.
Yeah, it's okay.
hello, can you hear me now?
Yeah, okay.
Yeah. So, in terms of the model test, I saw that you use fast patrol boat. Yes.
Yeah.
So, what about the result if you do with the trading vessel, for example, like a bulk carriers or tankers or containers, because that would be more relevant in terms of
Yeah,
EEDI.
Yeah.
Firstly,
Yeah, of
so
course.
secondly, have you consider to translate the total resistance reductions in terms of fuel saving? For example, like if you say 15% reduction of total resistance, how would that be translated into fuel saving? What is the percentage of fuel saving in your opinion? Because when you talk to the ship owner, then they don't care about the total resistance. That they would say, what is the fuel efficiency that I can gain from the expo? Yeah. Okay. Next, Marina.
Okay. I will answer the last question first. And yeah, actually, I didn't calculate what will be the full consumption will be getting from the reduction of the resistance. But it can be calculated because we calculate cost from the resistance by doing assumption to calculate the engine power, and then we can calculate the full consumption with a lot of formula we can use in the literature. We can calculate it that, and maybe I will come into that. Well, come into the what you ask, and of course, and the first question, of course, the petrol boat is not recommended by IMO to fulfill the EEDI regulation, but we can, in the next maybe because it is master degree, we have to give a paper in journal. So I will next I will doing a simulation and also to calculate the EEDI for like a bulk carrier or container ship. Pak Ika. Of course, container ship or bulk carrier, we can calculate because there are regulation, and with this reference line also is mentioned in the EEDI table. But for this patrol boat, it is not regulated in the reference line in the from IMO. But at least, even it was a military ship, so at least during this decade for carbon emission, military ship is because there is not wrong to contribute saving the fuel, decreasing the carbon emission by optimize the ship hull, Pak Eka. That's answer your question.
Thank you, Mr. Ridwan. Maybe the next question from the Zoom from Dr. Damora. May I inquire about the turbulence model used for CFD simulation? Thank you.
Oh, okay. We use a turbulence model. I use the turbulence model in this simulation. I use K omega and SST. So because this is usually used in the for high-speed vessel.
Thank you, Mr. Ridwan. I think we should go to the next presenter. Thank you, Mr. Ridwan.
Okay.
For the next presenter
Thank
is
you very much.
Dr. Muhammad Arif Budianto. Please share screen your presentation, Dr. Arif.
Yeah, good morning.
Ridwan.
Yeah, can you
Yes.
see my
Yes, it's clear, Dr. Arif.
Can I start the presentation?
Yes, let's start.
Okay, good morning to all audience. Thank you very much for coming in this section. In this opportunity, I will try to present our research with the title Levelized Cost of Energy Designing Portable Cold Storage for Tuna Fish Product. Yeah, in this project, actually, we work together with our colleagues from Department of Mechanical Engineering, Universitas Indonesia, with Safira Videla and Dr. Ardiansyah. The outline for this presentation consists 4 chapters. The first is introduction, and then the second is the research method, and the third is result and discussion, last conclusion. First, I will start with the background of this study that, as we know, the world capture fisheries and aquaculture production is increased year by year. As we can see from the left graph of left figure that the fisheries capture increase in case for the product tuna. And for the world biggest catch fishery, Indonesia in the 3rd rank for the world catch fishery. But in other hand, the facility in Indonesia are still not sufficient, and only 200,000 tons of frozen warehouse facility are available from the demand or the need of 1.7 million tons based on the Ministry of Fishery and Ocean. And the development assistant through the Directorate General of Marine Fishery that we need to design of the cold storage that proposed for the small island or small area that with the limited power source. So the objective of this study actually to design optimal portable cold storage. Now I will move the research method that begin with the data collection and then the capacity requirement, and we try to calculate the cooling load, and then we define the component specification, and also we calculate the power supply analysis, and we calculate the cost estimation, and last we try to levelize the cost of energy of the cold storage. The location that we choose for this research actually in Bekasi, near from the Jakarta Bay, and this area actually for the industrial area, but we actually have been developed the prototype in this location, and we try to measure some energy consumption and like that. And this is our design, that the cold storage is planned to have dimensions with the length is 7 meter, and then the width is 3 meter, and the height is 5 meter, with the total volume is 105 cubic meter. And the cold storage using the material polyurethane to use for the wall insulation, and strengthened with the stainless steel for the frame, and the polyurethane with the dimension is 80 millimeter, and with the density is 43 kilogram per cubic meter. And the thermal conductivity for the polyurethane is 0.28 watt per meter square. And for the heat cooling load calculation, we using the standard from the ASRE, American Society for the Heating, Refrigerating, and the Air Conditioning, that the consists of the external heat gain and then internal heat gain. That the external heat gain consists of the transmission load, and then solar radiation load, and air ventilation load, and also for the internal heat gain from the lighting, equipment, people, and also the cargo load for the tuna product. And from the summarize of the part of the load, we can get for the total cooling load. For the power source scheme, we try to variate for the 4 power source scheme. The first is for the generator set and cold storage, because the purpose is for the island that with the limited power source. So we propose the generator set and the cold storage. And then the second power source scheme, we use the solar PV with the battery. And then the third is combination, or we call with the hybrid power source, that using solar panel and then using the on-grid or on-grid of the power source from the what we call with the on state of electricity, or PLN. So we use combination between the solar panel and then on-grid power, and using the central electric panel or the energy management system. And the fourth scheme, we use the solar panel and battery. So this is the scheme is actually off-grid without any power source from the on-state electricity. So solar panel and generator set without the battery. So the concept is for the daylight, we use the solar panel, but for the night, we use generator set. So this is the component specification that we use. The first, that the condensing unit, we have a cooling load about 6.75, with the coefficient performance of cooling is 1.64, and based on our component specification, the power source that need to be supplied for this condensing unit is 4126, and for the refrigeration pump, we using the scroll type, that we with the cooling capacity is also same 6.75, that the power source is 4072 watt. And then for the evaporator, we use the fan input about 90 watt, with the airflow capacity is 1500. And this is our estimation of cooling load in the 7 days. So actually the cooling load is increased by the day until the 7 days, almost constant, because from the scheme that the cargo that using tuna is every day is increase the load. And also we try to estimate the energy balance between the demand of the power from the cold storage and then the power source that we have from the generator and also solar PV. And after that, we try to calculate the production cost from the every unit cost from the cold storage and the solar PV, also operation cost. And this is the result of the production cost for the cold storage that consists of the frame and then condensing unit, evaporator, and also the power source from the solar PV and then operation. And then we try to calculate for the operation cost for the energy source that using the generator. Actually, the operation cost come from the diesel fuel and then maintenance cost and something like that. Sorry, it's still in Indonesian rupiah. So the production cost for the cold storage for using the solar PV more or less is 500 million rupiah, and then for the operation cost using the diesel is around 3 and also this is the result for the levelized cost of electricity. So we can see that we have about 4 scheme. First is using pure 100% is from the grid or from the PLN, and the second is using genset, and the third is hybrid.
Sorry, Mr.
Between the gens. Yeah, okay.
Maybe you can.
Okay. Yeah, okay. Thank you. Yeah, using PV hybrid within generator and then off grid, with the grid and then PV off grid and PV on grid, and the levelized cost of electricity that the grid actually now genset actually now is the more cheapest than grid. Grid is using the PLN, and then the medium price is in the PV hybrid is about the 11,000 rupiah. And for the conclusion that we have been designed for the cold storage, portable cold storage with the dimension is 7.2 wide with the height 5.2, with the maximum cooling load is 7.14 kilowatt, at the power consumption is 7.93 kilowatt, and the cold storage production cost is about 500 million. That the operation cost for the diesel is 3 billion rupiah, and then the lowest LCOA that using generator set, and the largest using the off-grid PV. And by considering this balance, that we can consider the hybrid PV for the small area of for the limited power source. Thank you for your kind attention. If you have any questions, suggestion, we are very welcome.
Thank you, Dr. Arif. Is there any question from participant or from student? Oh, I think there is a question from Dr. Damora. May I ask what is the power output of the solar panel used? Thank you.
Yeah, actually the power output is in this case we only using the solar panel with the dimension is not so wide. We only use for the roof of the cold storage that with the dimension is 7 by 3 by 7 by 3, and the power output is for one day that we can see here is the solar power output for the PV at the noon is about 2 watt hour, 2 kilowatt per hour.
Okay.
This
Yes, it's very clear, Dr. Arif. Thank you. Maybe there is another question from participant. Oh, Prof. Relinson.
Thank you very much. Very interesting indeed. The graph that you've got up at the moment is quite interesting. The estimated energy balance. Am I right in saying that the orange colored line is the power coming from the solar PV, so that it tops at 2 kilowatts? Is that 2 kilowatts? But of course, a lot of the time it's night, so it's not getting any power. So what would be the power factor for the solar panel?
Actually now the power factor is if I'm not wrong, is 0.6 or 0.8 the power factor, so 60%.
It looks lower than 0.8, doesn't it?
Yeah.
I just wondered because we obviously, well, maybe you don't know, but in Australia we have a lot of people have solar panel. People are using them a lot. I have them on my own roof at home, and it's quite interesting to me. We have 6 kilowatts at home on the house, but it's something like power factor of about 0.2. So we're a lot of the time we're not using, and I thought that was more like the industry standard, 0.2 or something like that.
Yeah. Okay, thank you, Professor. We will consider the power factor. Yeah, actually now for the solar PV, there are many at current development. They have a high power factor and then using the bifacial solar PV or something like that. But in this time, because this is for the scheme that we use the power factor around 0.6 until 0.8.
The power factor also depends on how much sunlight you've got. That's why I'm interested. You're in a very different location from where I am in Tasmania. So
that's true. Yeah.
Different length of day and different length of night and different amount of sun. So I find the comparison very interesting. Thank you very much.
Yeah. Thank you, Professor.
Thank you. Is there any question? I think it's no. Maybe we can go to the next presenter. Please give applause to Dr.
Thank you
Arif
very much.
Thank you, Dr. Arif.
Thank you very much.
Is Miss Eka Sundera Putra. Please, Miss Eka, turn on your screen and share screen.
Yeah.
Sorry. I'm sorry. Okay, Mr. Eka.
Yes. Can you hear me, my voice?
Yes. The time is 10 minutes, Mr. Eka. So you have to present as efficient as possible.
Are my screen already visible?
Yes.
Okay. Right. So thank you very much. Good morning, ladies and gentlemen. Thank you for the time have been given to me to present a paper at an international conference on Ship and Offshore Technology Conference with a research title is Numerical Investigation on Build Skill into Roll Motion and Resistance Performance of a Traditional Finishing Boat. With list of authors Eka Sendra Putra and Eka Karnes Ilman from Ocean Engineering Program, Institut Teknologi Bandung, and Ahmad Fitriadi from Program of Naval Architecture, University Malaysia Terengganu. Starting from introduction, from the cultural aspect in Indonesia, especially in the South Sulawesi region, traditional sea transportation developed from the 14th century. The boat known as Penisi boat, it has also been nominated as an intangible cultural heritage by Indonesian government by UNESCO in 2017. In ancient times, pinnace boats were often used for trade, carrying goods and a few passengers. In this modern area, many pinnace have been converted into tourism activity boat. Therefore, their propulsion no longer use the stripe, but with diesel engine. And these boats are also expected to be able to carry a large number of passengers. From a safety perspective, it is still a concern for ship owners and operators, with construction still relying on traditional methods. Technical aspects are not really involved. So when designing a pinnace boat, is this necessary to do an initial analysis of the stability aspect and hydrodynamic characteristic, which is the case is specific to roll motion. When the passive stability system is the B-skill, where the B-skill is considered effective for installation on both sides of the hull on almost all types of the model of the ships. B-skill can also help increase the ship buoyancy relative to its rolling axis. But on the other hand, by adding a component to the surface of the ship's hull, it will definitely increase the wet surface area. So the value of the ship's resistance it will increase. The previous research also analyzed the effect of B-skill on roll reduction and the increase of the ship resistance value by Adi Maimun at 2008, testing of the hull plan of the petrol vessel using B-skill. With the slope of B-skill is 15 degrees, it was found the rolling amplitude are decreased by 18%, while the resistance value increased up to 14% at high speed condition. At the other research by Putra at 2018, also test variation in B-skill length so that the percentage of rolling motion value increase proportionally to change in the length of the B-skill. Therefore, it is necessary to carry out an initial analysis of the application of the B-skill in the initial planning of the pinnace boat, and this can improve the quality of stability and safety of traditional ship operations in Indonesian seas. Continue to methodology. This research used the Maxwell application, which is calculated with strip theory method, which is demonstrate a problem in the form of a frequency function. However, the result of hydrodynamic calculation are divided into several sections and in two-dimensional form. The roll motion involves several input parameters, including hull measurements by dividing the surface into several sections, and then mass distribution input to the reference point, and then involving the damping factors, which are given by Lewis in 1989, explaining that non-dimensional damping factors range from between 0.05 to 0.1, where in 0.05 for use for ships types without the roll suppression device like B-skill. On the other hand, ship's resistance analysis was also carried out in this research by comparing the impact of adding B-skill with variation in position and span. To predict the ship resistance, it's use the Holtrop method, where this method is often used for the V-shaped ship's hull and or the large L per B ratio length per breadth ratio values. By providing input parameters, speed for a sequence of float numbers are given. This is the ship data used to generate a three-dimensional model in Maxwell modeler and obtain the main calculation data such as length overall at 24.4 meters and length waterline 20.3 meters, breadth, depth, continuous shift drop shows on the table. Also, the maximum speed of the boat is 12 knots and displacement 76.65 tons and 0.4 for the block coefficient. The following step is a free roll decay test scenario plan and prediction of the ship's resistance. There are given variation models in 3 of width B-skill and 4 position of the angle slope, which is the 15 degrees, 25 degrees, 35, and 45 degrees. Also generate for model without a B-skill. For the simulation results, the result of the free roll decay test, the model used is the 15 degrees model with variation in damping factor or beta value, because in the strip method, the viscosity is not considered in the computation. The natural frequency is also greatly influenced by the input damping factor value. If we assume a damping factor value of 0.05 for the model without a bill skill, 0.075 and 0.1 for the model with bill skill, there is a decrease in roll amplitude of 14% compared to the model without using bill skill. Moreover, changes in the angular position of the bill skill affects the transfer ship projection, so it can involve to the damping incident value. The tests for predicting ship resistance have been conducted in calm waters with given variation of ship speed. The bill skill's effect on ship resistance is linearly increasing at maximum speed. The ship resistance for without bill skill models was 29.3 kilonewton, and for the model with bill skill the total resistance is 30.4 kilonewton. This event could be interpreted as indicating a 4% increase of the total resistance from a model without the bill skill. The following slide shows a graph of change in ship resistance values for each variation of bill skill model against to the span of bill skill. As previously explained, the change between models are insignificant as the peak that coincide at each point. And for the conclusion, the first is changes in the position and dimension of the bill skill great influence to the roll motion reduction. On average, assuming the damping factor used on the angle 15 degrees, 25, 35, and 45 degrees, model are decreased of 14% from the model without bill skill. Also, the comparison of the increase in total ship resistance produce a small percentage, only 4%, so that the application of bill skill on traditional ships is an important consideration for shipbuilders, especially analysis in planning the finishing boats. On the other hand, the method in this research needs to carry out a more specific analysis with good accuracy. Analysis can also be carried out using the CFD-based test with several study parameters for different bill skill variation. Therefore, in traditional boat planning, in this case, the finishing boat also involves technical studies. The safety issue can be achieved optimally with significant result. We would like to thank to research grant from ITB, Research Community Service and Innovation Program, and also to University Malaysia Terengganu for providing the MaxSurf application license. And several references for the use is in this paper. And that's the end of the presentation. Thank you very much and good morning.
Thank you, Mr. Eka. Maybe first from the participant, is there any question from the participant? Okay, maybe from the Zoom room, from Dr. Damora. May I ask more detailed information? What is included in the boundary condition for the simulation using MaxSurf? Thank you.
Yeah, for the boundary condition for simulation using MaxSurf, there is maybe the inlet and outlet condition. So the main point is on the front side is for the inlet pressure, and from back side of the ship is the outlet. So left and right side there is the maybe for the wave absorption, and for the top and bottom usually used for the external boundary. Maybe that's the point.
I think it's clear, Mr. Eka. And
Okay.
now MaxSurf is default boundary condition, not like ANSYS we can adjust. Okay, maybe the next presenter, Prof. Relinson. Yes, we have time, Prof.
Thank you very much. Very, very interesting presentation. I didn't quite understand the effect of forward speed on the roll damping. So I think if I understood rightly, you were getting the roll damping value at 0 forward speed, but have you looked at how it changes with forward speed, or is it just simply looking at 0 forward speed?
I just looking for the zero forward speed. So just the static free roll decay test. I not yet run for the forward input the forward speed for the roll motion response.
That makes sense, I suppose, because you're mainly interested in rolling at 0 forward speed. I just wanted to understand that, whether in fact you'd done anything at forward speed. Thank you.
Thank you. Thank you.
The next question from Professor Kap.
Thank you very much. This is a very nice work by Mr. Eka Swendra Putra. So your work showed us that when you edit the ship with build scale, will improve the rolling motion, improve the safety criteria for the vessel. However, it increases the drag about 4%. Based on your discovery. Do you consider to optimize? Actually, usually people would like to have reduce of the resistance, also improve the rolling motion, which is impossible. Do you consider when you improve the rolling motion and the increase of the drag actually not as much as 4%, say maybe 1 or 2%? Okay. Perhaps you can give some opinion about that. Thank you.
Thank you, Prof. Ikap.
So for my consider is to improve the roll motion and decrease the drag is maybe my opinion is from the how we design the build skill, and maybe also the hull shape is involved for the improve the rolling motion. I think that's my opinion.
Thank you. A lot of work should be done, for example, by placing the build skill at different angle, for example.
Yeah, correct.
Okay. I suggest you continue the work to have a better result in the near future. Okay, thank you, Pak Swendra.
Thank you.
Ikap. And thank you to Mr. Eka. I'm sorry, we have to go to the next presentation. So please give applause to Mr. Eka. The next presenter is Mr. Haikal Anjasmara. Please turn on your camera and share your screen.
Can my face be here?
Yes, it's clear, Mr. Anjasmara. And I will tell you there is only 10 minutes for presentation. So present as efficient as possible.
Thank you. Good morning, everyone. It is an honor for me to be the presenter at the International Conference on Ship and Offshore Technology 2023 in this occasion. Allow me to introduce myself. My name is Haikal Anjasmara, and I will present to you our research on the use of mode shape curvature method for identification of damage to the ship's ram door sandwich plate structure. The outline of this presentation is overview and background, finite element modeling, result and discussion, and the last is conclusion. The background of the study: the use of sandwich material as an advanced material in the shipbuilding industry is being carefully considered. This is due to the lightweight characteristic of sandwich materials and their favorable strength-to-weight ratio. By applying the sandwich material, the weight of the ship's construction can be reduced, thereby increasing its payload capacity. This undoubtedly enhances the efficiency of the vessel, allowing it to carry a greater load compared to ships using only steel as their material. But sandwich material also have disadvantage. Sandwich material can experience damage during the manufacturing process. One of the damage is debonding, where the layers of the face and core of the sandwich material separate, resulting in the detachment of the connection between the face and core. However, due to the structure of sandwich material, the debonding damage cannot be visually observed. So we need a method for identifying damage to determine whether there is any damage in the structure and where the damage is located. So this research aims to determine the dynamic response of damaged sandwich material ram door using the mode shape curvature method as one of the vibration-based damage identification for sandwich material. This is the finite element modeling description. The model for analysis is modified from existing configuration. For the top and bottom plate, existing design changed to sandwich material with configuration 3-15-5 is 10 for 3 mm for bottom face plate, 15 meter for core material, and 5 mm top face plate. The transport stiffener also modified from 16 stiffener to 12 for sandwich model. The debonding modeling is assumed from the effect that occur due to the manufacturing process. Damage ratio is the percentage of the debonding area compared to the total area of the core material. The debonding ratio used in this project is 20%. Debonding damage have 5% thickness of face material in the model, which is 0.25 mm. The boundary condition assumed to be used is clamp at both ends. For the result in this project, the absolute curvature shown in figure for absolute curvature from mode 1 to 5, it illustrates the change between a healthy and damaged structure. These curvature changes are localized, meaning they indicate the location of the damage that has occurred on the ram door. The location of the damage is indicated by the motion curvature in the central area. This aligns with the damage model created, which involve a square-shaped defect placed in the center of the sandwich core material shown before. In this, it could be seen that the debonding located in the center with the damage ratio 20% and square shape. As higher modes are employed in the structural analysis, mode shape's curvature undergoes notable change in its characteristic, impacting its effectiveness in detecting structural damage. With increasing mode number, these changes become evident. Firstly, higher modes tend to exhibit more intricate oscillation and increased number of nodal lines, rendering them more sensitive to localized structural alteration. This heightened sensitivity allows mode shape curvature in higher modes to detect even minor change or localized damage within the structure, offering improved precision. Secondly, higher modes provide greater local resolution in mode shape curvature analysis. This means that mode shape curvature in higher modes can pinpoint damage on a smaller scale and with finer detail. However, the complexity of this higher mode introduces challenges such as interpreting intricate vibration patterns and dealing with higher resonance frequencies, which may occur simultaneously. Lastly, the higher modes often exhibit more pronounced nonlinear behavior within the structure. This nonlinearity can lead to complex change in mode shape, resulting in intricate and less predictable alteration in mode shape curvature. In absolute curvature mode 5, it can be observed there is a curvature change located at the edge of the model, even though there is no damage component at that particular location. By using the average of the absolute curvature values for each mode, we could obtain the damage index value for each location. To identify damage, we can observe where significant change in location occur, as damage is inherently local. Therefore, change in mode shape curvature square can be interpreted as the location of the damage. In this instance, the MSCS index aligned with the damage location depicted in the debounding modeling earlier. Additionally, at the center edge of the ram door on the mode shape curvature square index, there is a slight increase in the MSCS. This increase in the mode shape curvature square index might typically indicate a location of the damage. However, it is a false alarm in this case, since there is no damage in the construct model. This could be attributed to the use of excessively high modes, leading to an increase in the MSCS index value, or the presence of an edge effect causing noise in the calculated vibration response. For the conclusion, the absolute curvature method has proven to be highly effective in structural health monitoring, especially for detecting damage in sandwich structure. By observing the increase in MSCS index, the location of occurring damage can be determined. However, the use of higher modes can complicate the analysis. Therefore, the selection of modes must be carefully considered. And the last one, it is crucial to account for the S effect that might arise in the obtained vibration response to avoid interfering with MSR's result and causing error in determining the damage location in the structure. I think that's all I can say for now. Thanks and good morning.
Thank you, Mr. Haikal. So maybe for the first question from Dr. Damora, he say, may I inquire about this presentation with whether the finite element method simulation include a mass independent test to obtain an optimal grid? If so, could you please provide detail on the grid model you use? Thank you. Please answer, Mr. Haikal, because
Yeah.
Your grid.
Thank you. There is a great independence or mass convergence in this analysis. The mass convergence analysis I use is 0.5 meter for the sandwich ram door, and the element created for the 0.1 meter is 43,000 element. In this presentation, I could not present it the graphic, but I have it in my report. Thank you.
Thank you, Mr. Haikal. I suggest to maybe for the next presentation, you have to provide your grid independent, because Dr. Damora don't see your grid independent, and we don't see your grid independent. Okay, thank you.
Thank you.
The next question for participant. Okay, Dia.
Okay, my name is Yusilena Pratiwi. I'm 5th semester. My question is, if the sandwich pod structure proves to be efficient in identifying damage to the ship's ram door, how about considering the associated costs? Thank you.
Okay, Mr. Haikal, answer about the cost.
In this research, I just identified the damage to the ram door, and I'm not research to the cost for the production of the sandwich ram door. That's all I can say. Thank you.
It's clear, Lia. Okay. Is there any question? Because we have still time. Okay. From the back, Rico.
Okay, thank you, Mr. Haikal, for your nice question, for your nice presentation. And there are two questions, and the first one is about your mode in this research, and then the Second one is, what is the minimum damage ratio that can be detected by your methods? Thank you.
The first one is the mode I use. The mode I use is 5 modes. First 5 modes in the structure sandwich model. The first 5 modes actually is the conservative method I use, because if I use too many modes, it could affect the calculation of the mode shape curvature square, and the result, there will be a noise where the damage is not present, but the graphic show there is a damage, like the mode 5 in the edge of the ram door. Maybe I suggest the mode shape curvature square in this ram door of mine use only 4 modes, because there's not really significant change on the other location of beside the damage location at the ram door. For the second question, may you repeat the question?
The minimum ratio for
the minimum ratio. Actually, there is no minimum ratio for the calculation of the mode shape curvature, but if the ratio is too small, the mode shape required to calculate the mode shape curvature square is also be higher, because if the ratio is small, the change in the curvature square is also significantly small. So it will not present in the so the change in the curvature square will not be present except you use the higher mode, but the higher mode will get you noise in the calculation. So maybe in the previous research, 5% is considered minimum for the damage identification for sandwich material.
So the method effective in the ratio, what's ratio, or maybe there are value of ratio?
I think 5% is the smallest ratio to use.
Okay, thank you, Mr. Haikal.
You're welcome.
Okay, maybe we still have time. The next question from Dr. Wiwin Sudiawati, STMT.
Okay, thank you for the time. I just want to ask how to make sure your result research. Maybe there was a research before about the sandwich for validation.
Yeah, for the validation, actually, I have a mass convergence analysis, but I didn't input it in the presentation. But I have a mass convergence to validate the final element model. Okay, this one.
Okay, thank you, Mr. Haikal.
Okay, thank you, Mr. Haikal. As I suggest to, the good validation is from the experimental data. And okay, maybe we have to go to the next presenter. Please give applause to Mr. Haikal. The next presenter is Hasanuddin. Please turn on your camera and share your screen. Mr. Andika is there in the Zoom room.
That's okay. I think Mr. Andika Sarifudin still not in Zoom meeting, so
we can skip.
Okay.
The next presenter is Mr. or Miss Amirul Baihaki is there in this Zoom? Mr. Amirul Baihaki, please share screen your presentation and you have 10 minutes to present your research data.
Okay, thank you.
Okay, let's start, Mr. Amirul.
Okay. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. Here I will present the result of our journey attended assessment of skipping behavior on catamaran with variation of Tembial separation with author Betty Aryani, Amrul Behaki, Ponidi, Artan Agra Kausar, Rizky Chandra Arista. The content of this presentation are the first introduction, then the catamaran health model, then the skipping analysis, which skipping analysis later the result of the ship's height, roll, and pitch, motion condition, and also the present path variation in terminal distance, wave height, and ship speed. And also the skipping analysis, the area wave roll and pitch will be explained for each variation of terminal distance. Then an MSI passenger of on MSI and analysis carried, namely at analysis generally the use the assess possibility that passenger or crew on board the ship will experience seasickness. And finally, there is the conclusion from the presentation of the journal. Next, the ships are sea transportation that are used for crossing between islands, especially in maritime countries like Indonesia, using a catamaran hull model which has the advantage of battery stability. So catamaran hull design are not taking into account shipping condition. This is because the water condition at shipping area have difference at good wind speeds and wave height. And second, catamaran have a terminal which has another function, namely as the wave breaker to stabilize of the ship movement when hit by sea wave, paying attention to sailing condition and ship speed. It is necessary to analyze the optional terminal distance model according to existing speed and wave. And this research can be used the reference when future research carried out. Next. In the initial modeling was carried out using the existing dimension, namely main dimension in like on the presentation, which distance between terminal, namely 16.5 meter. Then after obtaining the existing model, modeling was carried out for variation that were to be compared. Namely, the terminal distance was attained by 1 meter and minus 1 meter for the centralized to right and left. The calculation process was carried out using Maximum Motion Advanced software, which used the strip theory method. The analysis was carried out in three parts, namely forward, midship, and after. The speed variation, these are 6 and 12 knot and the wave angle used in analysis 0 degree to 360 degree with wave height of 0.5 meter, 1.25 meter, and 2.5 meter. The following area the result of running skipping for respond to have roll and pitch movement and first in the result of running the existing hull. The result in the table show that each of the three model does not show significant difference in change in wave height and speed. And second, the running result of the -1 meter demi-hull variation in this variation also show the same result, namely there are no significant result from the three angle and wave variation. The wave foundation is constant at all speed and wave height. There is no significant change compared to existing hull. Different conditions occur in a roll where 3 tend to be increase all speed and wave variation compared to existing model. However, change occurred in roll condition in the +1 meter demi-hull variation analysis, where the result showing the graph response for each variation in speed wave height, these results are considered quite significant compared to the result of the two previous models. And the RAO have first RAO have movement in a regular wave state. It can be seen the graphic image above. The response given to the existing hull model is large and look quite significant. Then other model variation whose frequency results are lower. And second, the RAO of the roll movement, wherein this movement the response given is not the significant visible, where the frequency obtained by the three hull model has almost the same number either in the hull model -1 meter existing or +1 meter. And our movement on pitch from the curve, it can be set to ship model with variation in hull distance +1 meter +1 frequency is existing model to high telephone. The result can also be seen in graphic image where the high frequency at -1 meter variation and frequency of 0.013 rate and decrease and 0.019 rate and decrease for existing model and +1 meter variation at 0.011 rate slash decrease. And in the result of running skipping motion sickness index or MSI, data was also obtained in from the graph the result which are first it is found that the value of the existing MSI index the quite small thus meeting the three ISO criteria.
Sir Amirul, 2 minutes left, so you have to speed up your presentation.
Okay. It ISO in can be criteria based on exposure and conclusion. Wave height and ship speed do not have effect of have, but this usual the inner have role and pitch value. The Demi health variation show the same response in half and pitch condition, but in roll condition, the analysis result show that the plus 1 meter model variation has a better response. This is proven the number displayed this condition for the three wave height variation, all three which show relative similar number compared to existing model, namely -1 meter. Thus, the presentation of our journal is lacking and we apologize for the access. Thank you. Assalamualaikum.
Thank you, Mr. Bayhaki. Is there any question or suggestion to Mr. Bayhaki? Okay, first one from Dr. Damora again. He's very active. Thank you for your presentation. May I ask, how is keeping measurement performed? And what instrument are you using? Thank you. Okay. It's very clear, Mr. Bayhaki. You don't mention what kind of software you use or what kind of experimental you use. Please ensure, Mr. Bayhaki. Hello, Mr. Bayhaki.
Okay. Can you repeat that?
Again. How is your keeping is measured? And what instrument you use? What software you use, Mr. Bayhaki?
Oh, okay. In this analysis, software use is Massive Motion Advanced. So, but this software is special for skipping analysis from Massive.
Thank you, Mr. Bayhaki. Is there any question from participant? Okay. Prof. Renelson, Mr. Rico, please give a mic.
Thank you very much. That's obviously an extensive piece of work that you've done. I found it very interesting, but I didn't quite understand. Can you go back to the slide that was headed Seakeeping Analysis? It's probably I misunderstood. Keep going. That one, yeah, the one you've just gone past. Keep going.
Slide.
This one.
Okay, this one.
I didn't understand. So this is, it says RAO of heave, and you're talking about different wave heights, but I'm not sure about the different wave frequencies. Is this irregular waves that you're looking at? And I didn't understand what's the x-axis. I'm sorry, I don't read that. What does that x-axis say? What does that translate to mean? I don't understand the word.
It's Indonesian language, Mr.
Yeah, what is it in
frequency in hertz unit?
That's frequency.
Frequency.
So how come it's always negative?
Why the frequency?
And why are the scales not the same? The one on the right goes from 0 to 2, and that goes from 1 to 3. I don't understand that.
Yes.
I'm sorry. Can you explain this a little bit more? For me, I don't understand.
Okay, Mr. Bayhaki, you can answer why frequency is negative and the scale the same.
Okay, so in this graph is the result of the data obtained from the running, so the same number, but this compared to when data is turns out like this. Yes, Mr.
I think it's not clear. He answered, Prof.
Yeah, I don't understand. It's my fault. I'm afraid I don't speak I don't understand the word at the bottom, which I think you said is frequency. But if that's frequency, I don't understand why they're all negative and why they go the left two curves go from 1 to -1 to -3, and then the one on the right goes from -2 to 0. I don't understand that. And I thought when I saw it at first, perhaps the word meant heading, because then the question is, what about different headings? So I don't understand these figures. That's my lack of understanding, and I apologize. But can you have you time to explain a little bit more? Or do we have enough time? Maybe I should read the paper when it comes.
Okay, yeah.
Yeah.
Maybe Mr. Bayhaki should read your paper and discuss again to your like frequency and and fix your all data. Maybe
Yes, I'll read the paper more carefully when it comes.
Yes.
Perhaps we don't have time now.
Thank you, Prof. Relinson. Is there any question? Because we have still time. Okay, from the Prof. Ikap.
Okay, thank you. Actually, it is a very interesting study when we consider seakeeping characteristics for the kind of ship hull. In this case, catamaran. Actually, simply we can see that if we increase the separation, then one of the components would be better. In this case, the rolling motion. Actually, I believe people in this room and online would like to know more of your explanation about the effect of the separation for heave, roll, and pitch motion. Could you explain this to us, sir, please?
Mr. Bayhaki, please answer.
Yes.
Maybe he still find the answer, Prof.
Okay, we can talk later, maybe by email. Yeah, it's a good work actually, I believe. Okay, thank you.
Okay, thank you, Mr. Have a lot of revision, fix issue, problem issue. You have to fix it. Maybe we have to go to the next presenter if he already in Zoom. Please give applause to Mr. Bayhaki. Is there Mr.
Bangsa. Cuk pola toleh cuk. Goblok.
Mr. Bayhaki, your language I will report to your
Oh, I'm sorry. This my friend. I'm sorry, sir.
This is a very rude word from Indonesia. Mr. Andika Sarifudin. Mr. Fari, is there Mr. Andika? No?
Yes. So I think Mr. Andika Sarifudin still not come to the Zoom meeting. So I think it's better for us to have a coffee break right now while waiting Mr. Andika Sarifudin to come. So yeah, now we will go to a coffee break for 15 to 20
Okay, we have to coffee break because there is many turbulence here. Let's have coffee, and we start from the laminar again.
Yes. Can you hear me?
Yes, yes, clear.
Okay. The Zoom meeting. So there is another presenter is Mr. Manuela still doesn't come to the Zoom meeting. So if he go session the Mr. Andika Sarifudin, can you hear me?
Yes, I can hear you.
Okay, so now we're still in coffee break. So I think
Yeah.
in 15 minutes or 10 your presentation. So please prepare it.
Oh, okay. Thank you. I will prepare it.
This Mr. Manuela Montoya, can you hear me?
Yeah, hello.
Okay, thank you. So your presentation will be start after Mr. Andika Sarifudin. So around in 30 minutes. Now we're still in coffee break. So just prepare it.
Okay, thank you.
Selamat siang. Selamat siang. Siang, 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 selamat siang.
Cek, satu dua. Cek. Cek, satu dua. Cek, cek, cek. Cek, satu dua. Cek, cek. Halo, 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 halo. Cek, cek. Tes. Cek, 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 cek. Tes, 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 tes. Tes, tes. Cek, 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 cek.
Cek, cek. Tes 1, 2. Cek, 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 cek. Cek, 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 cek.
Tes. Yes, okay, ladies and gentlemen, now we will proceed our event to the parallel session. For Mr. Fajri as the moderator, time is yours.
Thank you, Mr. Fahri. Maybe we should call the next presenter. Mr. Andika Sarifudin, please share screen and turn on your Zoom camera.
Okay, let me prepare my presentation before.
Okay.
Please.
Yes. Mr. Andika, can you prepare or share screen your presentation?
And turn on your Zoom camera, Mr. Andika.
Sorry, before I have a little problem here, and the file of my PC cannot open. Can we the next presentate it first? I have a little problem in my PC here.
Okay.
Can I present it next because of problem?
So, Mr. Andika, we can prepare your presentation from here. Is it all right for you?
Yes. Yes.
Okay, this one is your presentation, correct?
Yes.
Okay, so we can moderate your presentation from here, so you can just start your presentation now. For the next slide, you can please tell us when we want to go to the next slide.
Okay.
One more thing before you start, can you please turn on your camera?
Yes. Okay. First of all, thank you for the opportunity. Yes. Assalamualaikum warahmatullahi wabarakatuh. Good morning. Today I will present article with a title "Pitch Damping of Spar Platform with a Damper Plate Located on the Bottom." And where there is Hasanuddin, Faroka, Asidik, and Ali. Please next. Introduction. The increasing air pollution and the energy crisis have encouraged transition from fossil energy to new and renewable energy. One of the renewable energies that has continued to be developed in the last decade is wind energy through wind turbines. SPAR requires a larger damping to reduce the amplitude of heave, roll, and pitch motion so that the turbine can operate effectively and efficiently. Because the increase of the air pollution, so we conducted to make innovation of a spar that used for a wind turbine. Next. The methodology. The scale model to this model is use 1 to 115 with the model with and without damping plate. Principal dimension of a spar is diameter of dimension 14 to 6 meters.
Randika, Mr. Can you or Zoom? Tes. Okay, I think there's trouble with Andika. Can you hear my voice, Mr. Andika?
Yes, I can hear you.
Can you continue your presentation?
Yes, I can continue.
Okay, please.
Yes, the model scale used in the experiment was 1 to 115 with the model with and without the damping plate. Principal dimension of spar is diameter 14.6 meters, height 89 meters, draft 76 meters. Displacement is 11,677 tons, and height of the damping plate is 17.25. And you can see the figure on the right is the spar with a damping with the model of a damping plate. Please next. In the experimental setup, the free pitch indicators of sparse model were conducted in calm water conditions in a center wave basin of length 60 meters, breadth of the basin is 35 meters, and water depth is 2.5 meters, with the spar floating freely without any mooring. 100 to 115 scaled model with a damping plate mode of a perspex polymethyl methacrylate was used schematic diagrams of the spar models, and the left figure is the model of the spar with and without a damping plate, and the right table is the spar configurations of the real model to the scale model. As you can see, there's a height spar before is 89 meters to the 0.77 meters. Please next. And the numerical setup, the breadth and water depth of the numerical domain are the same as of the experimental test facility, while the length of the domain is 60 meters, breadth 35 meters, and water depth 2.5, with the spark floating freely without any mooring at the center of the domain. And the left figure is the domain of the numerical setup, and the right figure is the meshing model of the numerical setup. Please next. Results and discussion. And point where the pitch motion data trend starts to rise past zero is positive, and then decreases to a negative value and then starts to rise again is called one cycle. The left figure is the experimental setup. There's you can see the right line is the model of the spar without a damping plate, and the blue line is the model with a pitch with a damper plate. Yes, you can see the blue line is the little of the motion, then a red line. Because of it, we can conclude there is a reaction of the damper plate from to the model, and the right graph is a numerical setup with pitch motion. There is a result in there's effect of the damper plate. Please next. The second result and discussion is the natural period. For the natural period is the time required for a system to complete one complete rotation of a vibration when it disturbed from its static equilibrium position and returns to its initial position. The left table is each cycles of the model of the pitch decay. As you can see, there's different before adding a damper plate and without a damper plate. As the natural period is around 18.227 seconds and 19.1918 seconds. And the right table is the numerical setup. As you can see, there's a different on the natural period on the model A and model B. As you, please next. And the result and discussion 3, linear damping. The linear damping can be obtained through the decay test, obtain a linear damping coefficient using PQ analysis graph. As you can see, the A is experimental model and the B is with a damper plate. Sorry, can you?
Okay, please continue, Mr. Andika.
Hello, can you hear?
Yes, yes.
Yes, we can
Please,
hear.
please continue.
Test. Hello. Sorry, can you hear me?
Yes, yes. Please continue, Mr. Andika. The time is.
Hello.
Yes, Mr. Andika, you can continue.
Sorry, there's a problem. Yes. The trees. Please next. Key analysis from the numerical is 6,037 and model B is 70 million. Please next.
Sorry, Mr. Andika, there is only 2 minutes left.
Yes.
I think you should speed up your presentation.
Sorry, let's move to the next slide. Hello.
Okay.
Can you? Hello. Yes. The first of the conclusions is analysis of the predicated experimental method shows the addition of the increased damping pitch by 19.2%. The damping pad give additional damping moment to the structures, 12 bigger than before. And from the experimental test, found that lengthening natural period of the structure by 8.3%. And for the numerical simulation, found that lengthening natural period of the structure 77.5%. And last, as analysis between experimental and numerical method shows that the difference in patch damping is quite large. Thank you for the time. I give to the moderator break.
Okay, thank you, Mr. Andika. Because Mr. Andika, there is a signal issue, maybe. Is that the question? Or... Yes.
Okay, good morning, Mr.
Yes, good morning.
Yeah. Okay, very good. Is this your own patented designs or is this adopted from other design already exists? First question.
The model, yes, thank you. The model is already exists and the damper plate is my design.
No, what I mean is that is this innovative damper plate is your own design, or it is already?
Yes.
Okay, because I saw similar damper plate for some FPSO designed by company called Intexia, but nevertheless this is good initiative from your team. My second question is that whether because it's not clear whether you need to put that plate damper or not, because when you said about SPA, then we also need to know whether all these tensions on the leg is still within safety factors or not. Yeah, because if it is still within safety factors, then maybe damper is not required, because SPA is not about comfortability, things like that. So did you also investigate whether there is change on the leg of the spar? Because if the tension on the spar is still within safety limit, so what is the justifications to use this damper? You get
Thank you for the question. In my research, it's the floating of the spar, and that and there's and not concluding to the chain of the spar, and just the how the floating spar adding with the damper plate is not included to the tension of the leg of the spar. And there's a natural period here. There's what is the my research is not include the tension of the chain of the spar, and there's
I mean,
sorry.
Yeah, just to give you some idea, because when you talk about spar, it's not just the it's not just the heat frequency, but you also need to check on the on the tension on the leg, because if you want to approve your design by class, then they would look at the safety factors on that leg. It's not about the So I think you also need to consider this if you want to continue your research. Okay, but all in all, is a good initiative. Thank you.
Yes, thank you.
Okay, is there any question from participant? Okay, from Mr. Fatin.
Okay, thank you, Mr. Moderator, for your opportunity. Okay, Mr. Presenter, I would like to ask about one thing. Is there any discussion in your research related to the R square? Because I saw your data that the model A and model B is the spreading data is a lot. So, and I don't see the R square, or we can call it R square is coefficient of determinants. And yeah, I only ask you about is there any consideration about that? Thank you.
There's the consideration about the because of the heading of the damper plate cause lengthening of the portion of the spar.
I'm sorry, Mr. Andika, there is a signal.
Yes.
Maybe you can repeat again your answer.
Yes, there is a determination with the data, because the data of the model A and the model B, there's a difference before the heading plate. Natural period, and I think there is a determination.
So there is some discussion in your research about the R square. Am I right?
Sorry.
So there is some. I mean, can Mr. Dicky move to the results? Next behind. This one. Next.
Yes.
Next. Afterward. Setelahnya lagi. Satu lagi. Yeah. I see in the figure A and figure B, I saw that in figure B, I cannot see the y-axis is what it's mean, but I see that your data is spreading a lot. So my question is that okay for your research, or you not consider it in your final result? because as we know that every single, if we want to regret like your picture, we consider about R square, or we can call it determination of. Okay, that's it, my question.
Yes. So I think Mr. Andika Sarifudin already left the Zoom meeting. So yeah, I think we can continue to the next presenter for the better.
Thank you, Mr. Fahri. Maybe we go to the next presenter. Vera, please show your turn on your camera and share screen your presentation. Mr. Rivera. In this room.
Okay, hello.
Hello.
Are you call me?
Rivera, sorry, I'm sorry. Yes, you
Okay.
Rivera.
Yeah, I start. You can watch me. Yeah.
I can see you, Miss Rivera. And
Okay, so I will share my screen. Give me 1 moment, please. Share screen. Okay. And now are you see my screen?
Yes, yes. And
yes, okay, perfect. Okay, so okay. So hello, I am Manuela Montoya Rivera. I am aeronautical engineer and master in engineering, and today I will talk about the test bench proposal for energy consumption characterization of small scale electric boats. Today I am representing my college from Design Engineering Research Group from Institut University of Colombia. So the route that will be that we are going to follow in this presentation is the follows. First, I will introduce you in the topic. After that, I will discuss you the state of the art. Then I talk about the proposed design, and I will explain it in detail. And finally, I will share the conclusions. Okay. I don't know if you know, but in my country, Colombia, the rivers are so important. Colombia is the fifth country with largest waterways, and the 50% of population depends on river navigation. So you can see, as I say, that the river is so important. Also, the transport sector represented 39% of the energy consumption or the electric sector, and is expected that for 2025, the consumption of the oil reduced due to the penetration of renewable energy. Not in Colombia, but in other countries, the growing or the market of electric boats are in an impressive way. This market has a $5 billion in 2021, and each year has been growing 12%. So, for the implementation of the river electric navigation in Colombia, as for example, Serena, that is this boat, which is the first electric solar vessel for transport in Latin America, and where I had the opportunity to work last year, we need to validate the hydrodynamic function or performance of the hull in order to improve it. But it's usually done in towing tacks. First, are very expensive, and secondly, this not exist in Colombia. So for this, we propose a test bench that offer a good relation about a cost-benefit ratio. Okay, about the state of the art. So now you know that the electric boats are a sustainable solution for river mobility. However, the requirement could be 80 times the requirement that a land vehicle. So estimating the hydrodynamic drag is essential to optimize the design of the entire boat and other subsystems like propulsion, batteries, etc. The hydrodynamic evaluation of the vessel can be done actually in three main ways: statistical methods, numerical simulation, and experiments. About the experiments, it includes experiments with fuel scale boats or also with scale boats, and are done in recirculating water channels, towing tanks, or field experiments. Full-scale testing is the most accurate, but is so expensive method. And about the towing tanks, there are channels in which a trailer or car is mounted on one of pair of rails that guide the boat along the water channel. So statistical methods, they are a very useful and practical tool in the conceptual designs, but it could be a little bit inaccurate. And about the numerical methods, the most common is CFD simulation. It is used in the first stage of design, and we can know the detail of the behavior of the air and the water around the boat, but is very expensive in terms of computational resource. So the proposed design approach for test bench. For construction of an instrumental test bench, we use a design methodology that starts with a PDS, that is a specification of product design, and QFD, that is a quality function deployment. Also, we select the components and make a particle analysis, static and dynamical. All of this is taking into account the ITTC regulation and knowing that the test bench must be resistant, stable, and portable. This test bench allows us to calculate the power required by the boat in two ways. First, we know the cable tension plus the speed of the boat, and also we can know the power consumption by the electric motor of the test bench that pulls the boat. So we start the design, we made a list of requirements as a PDS, and this is translated into engineering specification as the first step of QFD. After that, this engineering specification I rated in a value to 1 to 5, being 5 the most important value, and give more importance to all the variables that give information about hydrodynamic deployment, development, or function of the vessel. And after that, we are proposed the variables and metrics for each requirement. So the test bench is designed in accordance with the ITTC regulation, and this states that the minimum duration of the test with at least 5 seconds, and to allow the data to be stable. The test bench is made from aluminum profiles and has these components. Okay, for the mechanical analysis, we make this free body diagram to know that the first pulley receives 2 times the tension of the nylons, and with this we can know the tension to convert them to the power recruitment of the vessel. And also we have to guarantee that the test bench didn't tilt. So because the the pulley of the nylon can generate a moment, and this make this calculation. And finally, in the figure of the right, you can see the experiment deployment, and with the equation of power, we can know how is the electric consumption of the vessel. For conclusions, the first conclusion, all of the calculation that I show are under ideal conditions, but they are so very important because that let you to know and to size the stresses to be supported by the test bench. The other one is that this test bench could be fabricated here in Colombia and reduce the cost of experiment with the scale ships and allow us to know the hydrodynamic impact and energy consumption of the vessel. And finally, for implement electric mobility and also electric vessels, is very important to think about the deployment of technology that also optimize the use of electrical resources in order to reduce environmental impacts. And these are the reference of all the work. Thank you very much, and I am open for your questions. I am not hear you.
You can hear me, Miss Rita?
Yeah, right now, yeah.
I'm sorry. Question from participant.
I suppose good evening to you.
Yeah, good.
Okay.
Hello.
Yeah, hello. I very interesting initiative here because I've never seen this test bench before, but this is very innovative. So congratulations to the team or yourself to that. Question is on the when you put use to vessel.
Sorry, I lack the song. Can you repeat me the question, please?
Yeah, can you hear me now?
Yeah, can you hear you now?
What is the material of the pulley that you use to tow the model test?
Okay, the pulley is a commercial pulley. Is maybe via plastic.
Okay.
I know it's a commercial pulley. We try to fabric or to use components commercial here in Colombia in order to give also reliable to the test bench.
Okay, so if you use pulley, do you also consider the elasticity of that pulley? Because then when you derive the resistant force, there is a component influenced by the elasticity of that line. Is this something you consider, or it can be ignored?
Okay, first we not consider the elastic of the nylon, but I try to compare this with also the power or the power of the motor of the test bench. So we have the force in the pulley that we measure with what is the name of this? Give me a moment. With a low cell, and also we have the power that is implemented in the motor of the test bench, and compare these two variables and this we can also maybe see that the resistance or the elasticity of the nylon is so important in the first measure.
Okay, so you derive from the measuring from the motor power as well as you put strain gauge on that pulley. Strain gauge.
You put what?
You put strain gauge.
No.
Tensor load. What do you, so you measure by just measuring the power from the motor, yes?
Yeah, I measure the power in the motor with a encoder and also measure the force of the nylon with a load cell. So we have two measure of power of the boat.
Okay. Okay, yeah, okay. Okay, thanks very much. Good work, yes.
Okay, thanks.
Okay, thank you. For the next question from the Prof. Relinson.
Thank you very much. My name is Martin Reynoldsson from Australia. That's a very interesting project that you have. We've tried something like this once before, and actually it was quite successful. But the way we measured the force was to have the force gauge actually on the vessel, so that you don't need to know what the power is on the land, and you don't have to worry about any flexibility in the wire. We actually put the force gauge on the vessel, where the nylon wire attaches the vessel. But my question really is, what sort of speed range and what sort of size of vessel are you planning to be able to test? And what happens at the end of the test? How does the model stop rather than continuing on into the shore?
Can you repeat me the question? I don't understand.
I'm sorry, the line is maybe not very good, but my first point was that you could put the force gauge on the model so that you're actually measuring force on the model or on the vessel. And we've done that with some good success. But my next question really is, how big a vessel are you planning to be able to tow? And what speeds are you planning to be able to tow this at? And finally, And finally, when it finishes the run, what is to stop it continuing on and hitting the shore?
Okay, so the vessels are scaled in order to 1 to 8. So we have more or less a vessel of 1 meter of length and maybe 23 centimeters of weight. And the velocity is maybe 7 meters per hour in order to accomplish the test with the float laws. So with these models, taking into account the length of or the size of Serena, that is the boat that I showed in the last presentation, and Serena actually has 8 meters of length. And how to finish the test is really I have to stop the vessel in the water. This is the only form to do it.
Thank you.
Thanks.
Is there any question from participant? No? Okay, maybe I have question to Ms. Rivera. I forget my question. Okay. Okay, I think I have a suggestion for you, Ms. Rivera. You can use float number.
Okay, this is the question. I I lost the connect. I lost the sound.
Okay. Can you hear
Right
me?
now, I can hear you.
You can hear me right now, Miss?
Yeah, I can hear you.
Okay, okay. I think I have just a suggestion. Maybe you can add fruit number as exchange to velocity, because in Naval Architect we usually use fruit number rather than velocity. Thank you.
Yeah, I tried to answer this in the last question. I also use the fruit number to scale the model. So Serena has a 8-meter length. So we make a scale for 1 to 8. The scale boats are the 1 meter length, and the velocity of function of Serena is maybe 50 kilometers per hour. So we do the test of the scale boat in a velocity of 7 meters per hour, maybe, to attach the float low.
Okay, thank you, Miss Rivera. I think we should go to the next presenter and give applause to Miss Rivera. I'm sorry. The next presenter is Dr. Muhammad Arif Budianto. Please turn on your camera and share your computer screen.
Yeah, thank you, Mr. Moderator, for your introduction. Can you see my screen now?
You can start, Dr. Arif.
Yeah, okay. Wait a minute. Yeah, okay, good. Still morning to all audience. Now I will present the second paper with the title Feasibility of the Investment in Fishing Vessel 30 gross tonnage. Yeah, this paper actually the project that we work together with Mr. Ahmad Faktur Utama. Okay, for this paper, will consist introduction, research method, result and discussion, and conclusion. Okay, the first I would like to try to introduce about this project. Yeah, actually, Indonesia have a lot of a big potential for the fisheries, actually for the catch fisheries, and many Indonesian is work as fishermen in the coast in Java, in Sumatra, and today around 2.2 million Indonesia work as fishermen, and this is and this is the map of the Indonesia, that there are many fishery port in Indonesia, and then so this objective of this study actually to design of the 30 GT fishing vessel with the for the drawing from the lens plan, general arrangement, and 3D design, and we try to calculate the what we call with the investment feasibility, and so this made for this project we try to come from the data collection and the defensive of dimension, and then we draw the basic design, and we draw lens plan, general arrangement, and then cell expansion, midship section, and also we calculate the feasibility investment, and last we also make a design approval to the Indonesian classification. So in the first, that the data that we collect, the first is the fishing vessel operation data, and then we using the data on the similar or comparable vessel, and also the regulatory data that apply to 30 GT fishing vessel. And the first we collect the major design of 30 GT from the Java coastline, and there are many design of 30 GT, and then we try to compare. And then this is the lens plan for the ship design that we propose. Actually, the difference between the current design with our proposed design is we propose the material is using the steel rather than the wooden traditional boat. So so we want to compare that between the steel vessel and then the wooden boat. And after we try to determine the ship particular, this is our dimension. The length overall is 16 meter, and then beam molded is 4 meter. And then we try to calculate the draft is about 1.2 meter, because in the fisheries port there are some limitation in the draft. So this is the maximum draft that we propose is 1.2 meters. And also the speed is 10 knots with the cargo capacity is 25 cubic metric. And also this is the general arrangement that we propose, that the cargo hold is only one single cargo hold, and then there are several rooms that can be fisheries can live it on board. And for this purpose ship that we didn't included the fisheries equipment, so only in the boiler and then only in the capstan. And also we designing for the midship section. In this design, actually the steel plate have the thickness from our calculation is minimum is 7 millimeters. And this also the cell expansion, we also make this design because we submit this design to the Indonesian classification. And also we try to calculate from the design to the cost estimation. The first, that from the ship material cost, and then ship equipment, engine and pump work, labor costs, and miscellaneous expenses. And from the owner cost estimation, we obtain about the $300,000. And from the financial analysis that we try to calculate within 20 years that we calculate, we have with the operation, actually the fishery ship is depend on the how many times that the ship is operated. So in this design, we assume that the ship will be operated 7 times in a month. Minimal is 7 times in months. With the fish type is the squid, and based on this assumption that we get the positive net present value, and with the rate return is 13%, and this is the economic result that we have. So last, and from this project, we can conclude that we already design and calculate the 30 GT steel fishing boat, and also the dimension is with the overall length is 16 meter and the draft is 1.2 meter, and also we calculate the financial analysis using NPV and IRR, and we get a positive value. So we can propose for this design to our investor. And that's all for this presentation, for this paper. If you have any question, suggestion, we are very welcome.
Okay, thank you, Dr. Arif. There is any question? Rico?
Okay, good. Thank you, Dr. Arif.
Yeah.
Two questions,
Professor.
Yeah, two questions. First one, this one you mentioned that this one is design is you submitted to the BGI.
Yeah.
Is it considered against Torremolinos standard? Yes.
Yeah, actually, the standard is we based on the what we call with the NCVS standard. So non-class. Actually, in Indonesia, we adopted the NCVS standard, non-class vessel standard.
Okay, not Torremolinos.
Yeah.
All right. Okay. Second question. I remember in late 90s, 19 somethings, BBPT, we have a project called Mina Jaya. To be honest, it was not so successful because at the times when we have to implement the designs to the all the fishermen in Pantura area, it was not well accepted by the local fishermen. So this design been built and introduced to the investors? It's only this concept. What if it is still in concept? What is the plan to introduce this into the traditional fishermen in particular? They are very they are very particular in maintaining some sort of traditional characteristic in the fishing vessel.
Yeah, that's true that our government have introduced the Incamina that at that time that we have information that the project is the material is using the fiber, and in this design actually we promote or we propose for using the steel because in our opinion that the investor from the what we call with the non-government investor or private sector, they want to insurance their ships, but because the material is wood and then fiber, the present value is very low, and then we try to propose using the steel, and actually that we have been built for the 10 gross ton for the ship using steel, but for the 30 GT that is maybe some challenges to promote to the private sector because the cost is maybe is 1.5 more higher compare with the wooden traditional boat.
Okay, so just one last question, because you mentioned GT design.
Yes.
So that has been successfully implemented, yes, or is it only design?
From the 10 GT already operate.
Yeah. Is that wooden or steel?
Still.
Okay, so this 30 GT is still conceptual, isn't it?
Yeah. Still design approval from the local classification.
Okay, so sorry, last one more. So you mentioned that the cost is 1.5 times higher than 10 GT.
Yeah.
Consider, for example, if the fact that this is still HAL, meaning that that you need to also consider maintenance.
Yeah, that's correct.
This is already considered, yes.
Yeah, that's right. Yeah. In other hand, from the capital cost that 1.5, but yeah, from the operational cost we already not calculated yet. But from the bank financial fund is more bankable, what we call, with the steel material.
Okay, thanks very much.
Thank you. Is
Thank
there
you.
question? Okay.
Yes. Okay. Dr. Arif, did you hear me?
Yeah, clear, Professor.
Okay, thank you for your presentation. I'm interested about this vessel. When you decided about the ship particular like length, beam, and the other, what you consider about this? I think that the user is the our fisherman, Indonesian fisherman. As we know that our fisherman is very difficult to make adaptation with the new concept about the fishing vessel. Did you make a discussion with them about your vessel? So how about your opinion on this issue? Thank you.
Yeah, thank you, Professor Adi. Yeah, actually, the design consideration that we collect from the data that we have been visited. So actually, we visited some fishery spot in Java, particularly in Muara Baru, and then in Tegal, and then in Banyuwangi, and then the south is in Cilacap and also Sukabumi. Yeah, actually there are no standard design that no standard design for the fisheries. That there are several design. Muara Baru different with the Banyuwangi and different with the Sukabumi, and then like that. And for your question, from your question, that we try to compare. Actually, this is the design based on the design in Muara Baru in Jakarta. And then we compare with the basic design in the Muara Baru with the wooden boot, and then with the similar gross tonnage, and then we calculate with the comparative analysis, and then we try to adjust in our design in based on MaxSurf and then so on like that, and we fix the gross ton, and then we can get the length and beam and draft or so on. So actually we try to modify from the Muara Baru design.
Okay, thank you.
I hope that's clear.
Okay, thank you. Is there any question? Okay, from Arhan.
Okay, thank you. I will ask that is whether you consider the ship can be produced locally by the local craftsman or a shipbuilder, so the resistance from the local people is less than what we seen in the past. Thank you.
Yeah, actually, from our project experience, that from the 10 GT, actually we try to put it in our campus and in our what we call with the traditional shipyard in Teluk Naga, maybe you know. And actually no, the production is not in the shipyard. So in our design, yeah, there's the vision is our vision is that this ship can be produced by the local small fish yard, that with the type is modularization of the uh, uh, structure. So for the 30 GT, actually we agree that for the local can be produced this design.
Thank you very much.
Okay. Maybe this is the end session for you, Mr. Dr. Arif.
Okay, thank you very much.
We have to give applause to Mr. Arif. Okay, the next presenter, I think is offline. I think. Yeah, this is offline presenter. Mr. Ramadan Farhan Fadilah, Ika Prasetya. Okay. Miss Ika Prasetyawan. Oh, Mr. I'm sorry.
Tes.
Okay. Okay, good. Still morning. Good morning. Before lunch, I hope everybody is still waking up. So, I would like to share with you rather than presenting. This is share. Unlike the previous papers, they're all about hydrodynamic fluid elements, complicated methodologies, and experiments. This one is simple arithmetic and it's not experiment. This is real case and it's still happening now. So the sentence is basically integrity of a mooring system, monitoring of integrity mooring system using what we call as an RBI. I will tell you in a minute what RBI is. Slide 2, please. Okay, some rationale. Why are we talking about mooring integrity and RBI? That's the two keywords. Next slide, please. You'll see the result when the integrity fail. Yeah, so we are talking about mooring system. When the integrity of systems fails, then it costs a company over $1.8 billion. This is accident in 2013 of FPSO called Griffon Alpha. Yes. So this is North Sea FPSO, and the one mooring line failed. So one mooring line failed because of that event. Then there is a serial, what we call a serial failures of the other three mooring lines. So it costs 1.8 billion to the company because you need repairs, and also because of the disadvantages of the operationals being held for sometimes what they can resume normal. Next slide. So what is the integrity? So integrity in this case because we are talking about the mooring system, is the process for ensuring that mooring system is fitness for service. How are we going to do this? Is to detect early degradation of mooring component as early as possible to allow for remedial actions. Now, there are two things. Most of you would recognize time-based inspection. This is class inspection. Normally, you would hear about annual class, spatial survey, annual survey. This is time-based. Time-based is irrespective of what the floating unit is, then you will get certain time-based annual intermediate every 2.5 years and then 5 years interval. But mobilizing people offshore is expensive. You would need to hire personnel, and you need to hire a tugboat. hundreds of thousands US dollar per attendance. So then we introduce another alternative called risk-based inspection, which is based on risk but not based on time. Next slide, please. Okay, in 3 minutes. I hope this in 3 minutes. Next slide. This is basically the RBI is basically we assume the process of degradation based on the inspection. Yeah. So this floater we need to gather underwater inspections from the previous survey, and then we can assume of degradation. But for example, in terms of corrosion, we can actually assume degradations based on most rule would be, for example, like 0.4 millimeter per year. But here in the tropical, like in Indonesia, it could be worse than that. So then when we assume degradation, then we determine what is the probability of that component fail. And then we determine what is the consequence. And from these two items, then we can determine the risk matrix. It is from this risk matrix, then we can find the inspection interval. The inspection intervals hopefully would be longer than 5 years, with the hope that we can reduce the OPEX or operational expenditures for maintenance. And then the cycle will continue because this RBI is dynamic. Why is it dynamic? Because the degradation may change. As the assets aging, degradation rate change. You will not get the degradation the same like if you are getting old, then your degradation when you're aging, then your degradation rate is changed. You know, you feel like all this, your body is aching and all that. So next slide, please. So this RBI is a project specific. Unlike time-based can be applied to all kind of offshore unit. This RBI is a project specific. Why? Because floating unit, they located in a different area of the world. The sea will have different chlorine, chlorine content, so they have a different corrosion rate. They have these different met oceans. They have different mooring system layout and so on and so forth. So next slide. We are now talking about the implementation on a real case. Next slide, please. This is the FPS that where we implement the RBI. This is floating production system, semi-submersible LR class, operated by Shell, located about 50 miles northwest of Sabah. 1,200 meter water depth. Next slide, please. Mooring system, there are 4 sectors. Each sector, there are 3. So in total, there are 12 mooring lines. Next slide. We have 72 mooring components. We incorporate those mooring components into RBI calculations. Those mooring line parts are platform chains, which is at the top chain, and the middle, there is a wire rope, and there is an anchor chain at the bottom, and then there is a firelit underwater. You will see these schematic graphics in the next slide, please. Okay, this is semi-taught system. Yeah, maybe you recognize from your offshore engineering lecture. Semi-taught system, we use upper wire rope, lower wire rope. In the middle between upper and lower, there is a connectors. Similarly, there is a connector between upper wire rope to platform chains, and another one from the ground, from the lower wire rope to the ground chains. The platform chains is, if I'm not mistaken, 125 millimeters diameter R3 grid. So wire rope is sheeted wire rope. Next slide. The connector is illustrated like this one. This is the real one installed on that unit. So this connector connect between upper and lower, also connect between upper and top chain. Next slide. There is one more component we also include in the RBI called the fairlead. This fairlead is located underwater. You can see there's about 10 meters from the mean water line. The fairlead structure is like this one here. The top chain will go through the fairlead, and there is a wear pad to hold the chains not to move when the RPS is heaving. And there is a few, which is called the small window there for visual inspection. When you deploy a diver, then the intention is for the diver to check on the physical condition of the chain inside the fairlead. But in reality, that is almost impossible because the fairlead is covered with the heavy marine growth. And recently, the company used robotic crawlers to crawl inside the fairlead to clean the marine growth, to check the physicality and use photogrammetry to measure the thickness diminution. But that's another topic.
I'm sorry, Mr. Prasetyawan, 2 minutes left.
Okay. So next step. Okay. So the risk that we are calculating POF, or probability of fail, multiply the COF, or we call it consequence of failures. So what are POF and COF? Next slide. So there are 1, 2, 3, 4, 5, 6, 7 contributing elements to the POF. You can just see it from there. We incorporate all the factors: accidental damage, anomaly, coating condition, corrosions, etc. And then next slide, please. And then we see at the consequence of failures, we will see affective factors. So the POF is the contributing factor. This one is affecting factor. What does the fail of that component that will affect the asset? So we rank all these consequence factors into high, medium, and low. Next slide, please. So within those ranking of low, medium, and high, there is a background calculations, which is of course proprietary. And then we just quantify those medium, low, and high into a number. And when we multiply risk equal POF times COF, then we can determine whether the multiplication is within low until high risk. When we incorporating all the components, then we found that all the components are within low and medium risk level. So that translates into the inspection interval. We found that from 5 years interval, we can postpone and make it into 6 years. So from 5 now we allow assets to do routine inspection every 6 years. So this may not seems much, only 1 year, but this asset is still young, 5 years. So they still got 20 more years to operate. If you translate that 20 more years, 20 more years divided by 5 is 4. But 20, if you divide by 6, then it's about 3 attending. So it's about like a 20% operational cost saving. I mean, that is a very rough estimation. Next. Yeah, so key takeaways. So this one RBI is something which is relatively new, but class similar like class like LR or DNV or ABS, we can accept these RBI. And then we do review on all the documents and the underwater inspection report and the RBI study document. As long as the level of assurance can be maintained, then we can accept RBI on the underwater component. But as I said, during service life, changes to asset are inevitable. Similar if we are when you're still young. So RBI plan, this is something that you should we should sort of audit every 3 years. Why 3 years? Because when you do the 5 years interval intermediate survey is 2.5 years. So 2.5 years, the latest intermediate survey will be 3 years. So that would be the interval that we use as a basis for RBI audit. Also, we found that RBI is only applicable for young asset. Young asset meaning that if asset is still within first year cycle, when you get into second year, is still maybe still applicable, but for the aging asset, it may not be that applicable because the calculation will give you 5 years result, which is the same as the time. Only young asset which can be economical to apply the RBI plan. I think I try to squeeze everything into 10 minutes. But thank you very much.
Thank you. Is there any question to Mr. Prasetyawan?
Okay, thank you, Mr. Rika Prasetyawan. It's very interesting about the risk-based inspection in your in the last page that risk RBI law register already accept about this, right?
Yeah.
So my question is, if the RBI applied, so it is possible to cancel about the time-based inspection? Is possible or not? So if I have SIP and then I use the RBI, so I can ignore about the annual survey, special survey, the other, or how about this? Thank you.
Okay, thank you very much. Yes, good question. So what the result of the RBI is the maintenance interval. Yeah. So from 5 years, you got maintenance interval. In this case is 6 years. It means that your special survey is perioded by 6 years. 6 years. In between, you still need to have a special survey, normally in the middle of those special survey. But for this special facility, they use terminology called continuous survey hull or continuous survey mooring system. What it means is that we give the clients 6 years window to complete everything. Yeah. So meaning that instead of having five years span, you get 6 years. It's not necessarily, does not mean that you ignore the 5 year. You still need to take all the requirement, but instead of 5, now you can complete within 6. In terms of offshore, this is significant because you can postpone mobilization a year, but then you see this is not just one cycle because you have remaining cycle until end of life cycle. So the economical saving, it could be significant. I cannot say the exact value because we are still doing it now, but we are looking toward reducing the frequency of offshore surveyor interactions because of this. Yeah. Yes, Professor. Thanks.
Thank you very much. It's of course very interesting and a little bit along the same lines of what I was talking about yesterday, to a certain extent. I guess a couple of questions or points. First point, I suppose, I'm not sure where the 5 year came from in the first place, but probably that wasn't a bad guess.
Yeah.
Because that was a long time ago.
Yeah.
And you've proved technically that actually you can maybe extend it a small amount. So that means the 5 years was probably a bit conservative, which probably was appropriate a number of years ago with the technology appropriate. So actually you've validated what LR has been doing for a long time.
That's true. Yeah.
But the second point, and I think you made this, presumably as time goes on, you won't get it 6 years each time. As you say, we are aging, it'll become less. Do you think it's likely to become, 2 questions, do you think it's likely to become less than 5 years into the future? And also the example you've shown, you've been able to make it 6 years, but you did make the point at the beginning that it's dependent on the particular application. So in other applications, you might also find, it should be less than 5 years.
Yes, it's excellent. Yes, good question. So okay, the 5 years is class rules. So that's the regulation. So 5 years is there is no derivation from that, because all class we accept 5 years is the special survey. We call it special survey. And the second question, what if we use another? Oh, okay, yeah, okay, yeah. So yes, 6 years. This proprietary arithmetic calculation we validate with LR experience for other project, because initially we implement this for onshore what's it called, power plant. Yeah, but having said that, corrosion degradation mechanism is the same. Yeah, apart from adding on load utilization, fatigue aspect, and all that. So if for sometimes the calculation from 6 become 4, for example, then the 5 year will still applicable, because that is the class. So that's what I said. If we introduce this software or this application into the aging asset, it may be that we are going to ending up with 4, which is not economical. We still can, but we can still stick to the class regulation, which is 5. Yeah. Yes. Okay. In the calibration, we will sort of tune up. This is not going to be reduced, like less than 5. When I say tune up, of course, this will be based on all these application, based on the implementation on the other project. We have a very limited example for the floaters, because as I said, this was generated from onshore facility, but all these degradations we take into consideration from the corrosion on the piping, rigid piping, and so all and all that is the same. Adding on the fatigue and so on and so on. But yeah, but then we don't want to end up, we don't want the software to result in a sort of 3 years or something like that. Then as you said, then you can argue, no, I want to, because of the But then we would advise the client beforehand that there is this fatigue sort of parameter, if you like. If the fatigue parameter is low, then we would say, okay, you don't need to proceed into RPI, because you are fine with the what you call, we are fine with the time base. Also, as you said, during the underwater, surveyor would need to see the physical condition of the chain, for example. Yeah. So even, for example, that chain is warranted for 3 years inspection, for example, we can see that because the diminution is so maximum, then we would say to them, look, your diminution is very, very minimum now. It is time for you now to replace that chain. So that is sort of like a safeguard, rather than 3 years. Even if, for example, the result is 3 years, then there is an indicator that this is due to this condition. Yeah. So there is like a fail safe in there. Yeah. Other thing is that, what if somebody using the other software? As far as I know, RBI approach is very subjective. My opinion, because if you see the manual or manual, this is based on risk, and risk is something that we cannot agree. What I mean is that when you do the hazard study or risk study, You need to sit together with the facilitators or the operators, maintenance, and the expert, and then you would say whether you putting back in here is a hazard or not. Somebody would say this is a hazard because somebody may trip. Somebody may say no, this is not a hazard because it's okay. So then, what is the criticality? Is it low, medium, or high? Then there is a different number. Yeah. And the consequence too. Yes. Yeah.
Thank you, Dr. Setiawan. Please give applause to Dr. Setiawan. I'm sorry, Prof. The time. Yeah, there is a. Yeah, I'm sorry, Prof. Oh yeah.
Do you use confident level for calculation? No, we don't use confident level for calculation because we don't use probability function. We assign between whether the risk is low, medium, or high. So we don't use the confidence level. So we use low, medium, and high. When we say low, what is the score? When we say medium, what is the score? When we say high, what is the score? So then we put that score on the POF that I explained before.
Thank you, Dr. Setiawan.
Okay, thank you.
Please give applause to Dr. Setiawan. Okay, the final presenter before we launch, Mr. Farhan. Oh, so I'm sorry. Because we have to go to lunch. Thank you, everyone, and have enjoyed the lunch.
Okay, please. Now we have lunch time. Tes. Tes. Tes.
Tes, 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 tes. Tes, 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 tes. Tes, 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 tes. Tes, segini dong. Okay, ladies and gentlemen, we would like to continue our meeting in today. So I will continue the presentation from Mr. Arif Fadila, Mr. Rizky Raihan Fadila, and Mr. Ramadan Farhan Fadila. With paper title is Study on Effect of Trim to Fuel Efficiency in Fishing Vessel. For Mr. Farhan Fadila, time is yours.
Yes. Okay, Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. My name is Farhan. Today I will present to you study on effect of trim to fuel efficiency in fishing vessel. Next. So this is the summary. I will skip this. Next. Okay, next introduction. Now, the background of research is that first, small pelagic fish potential is enormous at around 4 million tons annually, and 2 and 30 GT fishing vessels are required for small pelagic fishing. Number 30, most fishing vessels at WPP 712 and 513 are under 5 GT. So there a gap. They not fulfill the requirement needed to catch the small pelagic fish. Next, our ships are responsible for more than 18% of nitrogen oxide pollution and 3% of greenhouse gas emission. Next. Now, this is a problem formulation. First is that how to analyze the resistance of 20 and 30 GT ship. Second is how does the trim influence resistance, fuel consumption, and emission of the fishing vessel. 3 is what is the ideal speed for each fishing vessel. 4 is what's the ideal trim for each fishing vessel. And 5 is what is ideal combination of trim and speed for each fishing vessel. Okay, next. Now, this is the benefit of research. Obviously, it's give economical and ecological benchmark for fishing vessel. Second is reducing the fuel consumption and emission created for fishing vessel. Next. Now, this is a problem limitation. The study is only limited to two types of fishing vessel, the 20 GT VNH and 30 GT VNH. VNH stands for Type V multi-purpose net hauler. The speed varies only 5 to 10 knot with increment of 1 knot. This speed is acquired from the technical data of the ship. Third, its stream is limited to -1 meter to 1.1 meter due to accordance to IMO rules. Fourth, the distribution of load in the ship to achieve the trim, the required trim will not be calculated. Okay, next. Now, here's the hypothesis. The positive trim will reduce resistance more than the negative trim due to more reduction in the wetted surface area. Second is the higher the speed will make more resistant. And third, it's the more resistant, the more emission it will create. Next. Now, here's is the literature review. First is that trim is a condition where the draft is unequal. So draft in forward and after draft is not equal. Second is ship resistance is the magnitude of force exerted by the water on the ship hull as a result of motion. Ship powering is the required energy to operate ship at specific velocities. Fourth, it's gas emission from ship are real such gas like CO2, NOx, SOx, and PM. Next. Now, here's the governing equation. For example, the maximum trim that's from IMO rules is 1% of the LOA or LBP squared divided by GM1. Next. Next data. Okay, so this is the main dimension of the ship. First is the LOA of 20 GT is 17 meter and the 30 GT is 20 meter. Then the speed surface of the speed is 8 knot, but they can reach 10 knot if you force them, you overclock them. Next. So this is the lines plan. The lines plan is recreated from RINA Maritime, the project that happens in 2016 from Indonesian Fisheries Ministry. Next. The same thing happened for the 30 GT strip. It's from the same project from 2016. Next. Now, this is emission factor according to European Emission Agency. This is simply by multiplying the power required to this factor can generate the emission that will be generating by the ship. Next. So here are the result. Next. So there's probably some confusion. So the 0.1 meter trim, it's equal to 0.337 angle of degree. So next, zero is obviously zero angle here. Okay, so this is the speed and power graph. So there is no much different in this graph. It's due to next, because sorry, next. Okay, so because the reduction of WFO, it's actually small. It's less than 2%. It less than 2%. It's around 2.9, 1%, and something. So the minus indicates that there is an added resistance to the ship from the trim, and the plus is that there's actually a reduction. Okay, previous one. So for each ship in 30 GT at 0 meter trim, this is the emission that it generates. So the emission kilogram per ton, it's mean that for every ton full of ship use, a kilogram of the emission will be created. So this is so there's a WFO or fuel oil that's be used for each speed in 400 nautical mills, and then there's the emission. Next. So the conclusion is stream optimization can reduce fuel use and exhaust emission due to reduced engine workload, reduce fuel consumption result was found at ship speed at knot speed average value of 0.03 for 20 GT ship and 1.1, 0.9 for 30 GT ship. Due to the limitation of this study is only limited to type of fishing vessel, more models of fishing vessel operating in Indonesia are needed to get more accurate result, especially for reducing fuel use and exhaust emission, so that this study can be more accurate and can be refined in the future. Okay, thank you. I give back to moderator.
Okay, thank you, Mr. Farhan. I would like to go to the Zoom setting. Is there any question? No? Okay, I would like to go to the offline setting. Okay, Pak Ika.
Okay, thank you very much. Interesting research. Can we go back to the emission, please? The table of emission. The type your table where you show us the emission CO2
emission factor.
Yeah. It's not emission factor. It's
emission generated.
There is a trim 0, -1, 1, and then there is a emission.
Before.
Yeah.
This one.
Yeah. It's not a question. It's just a suggestion. So yeah, this is fine. Yeah, thank you very much. Yeah. So it's just a suggestion. Yeah, because if you follow IMO standard,
yes.
IMO emission you should measure kilogram per ton nautical mil. So you should change that instead of kilogram per ton. What is the kilo? That is kilogram carbon, isn't it?
So basically, we measure the density of the carbon.
Yes.
And for each ton of fuel generated, it will generate X kilogram of the carbon. That's basically what it is.
Okay. So just my opinion, because there is when you follow IMO resolution, when you mention about emission, you should use a unit of gram carbon emission per nautical mile, and then there is capacity. Capacity mean gross ton of your fishing vessel. So meaning that if you emit, for example, in this case 1.6, is that 1.6? Yeah, 1.6 kilogram. Then you should change that into 1,655 gram divided by nautical mile multiplied by capacity, which is GT. Yeah. So just your suggestion, because that is the emission factor recognized by IMO. So then you get more maybe more sensible results. So you may want to change that. Just a suggestion.
Okay. Thank you very much.
Thanks.
Thank you, Mr. Rika. Is there any question in here, Professor Martin?
Thank you very much. Very interesting paper. And of course, you had to go by the nature of things very quickly through it. I look forward to reading the whole paper because there's a lot of information in here, and it's a very sensible thing to do to try and optimize the trim. I suppose my question is, depends on the draft what the optimum trim will be. So if the fishing boat is fully loaded, it might have a different optimum trim than when it is light loaded.
Okay, thank you. So yes, I do not vary the load. I assume it's at maximum load. So yeah, I only use one kind of load.
Yeah, and that's very, very good. That's a good starting point. But I suppose what I'm saying is maybe if you can continue the work to give the fishermen advice as to if it's half loaded, what the trim should be, and so on. And I just have you right at the beginning you said you had the definition of trim. Can you put that up again? I didn't
yes.
quite follow.
With
something there I didn't follow.
Before.
Before.
Yeah, no, this one. The one we just looked at. So you've got the maximum trim is 1% of the LBP squared divided by GM.
Yes.
But I don't understand that. That's going to be dimensional, of course, because LBP is meters. So squared means meters squared, and GM is the metacentric height.
Yes,
Yeah,
it's
and so that's in meters. So that number is a dimensional number. I don't know where does that come from.
Yes, it is dimensional number. So that's why my trim it's on a meter because it's 0.1 meter and minus 0.0 meter.
Yeah, I can understand the equation above, which is the trim is the difference between drafts.
Yes.
Yeah, but I just don't understand that next equation, trim maximum.
So according to SOLAS, there is a limit due to safety factor and stability issues. So,
so they don't allow you to have a larger trim.
Yes, it's then.
I'm not familiar with that.
Okay, thank you.
Yeah, I understand now. Thank you very much.
Okay, thank you, sir.
Thank you, Professor Martin. Is there any other question in this room? Okay, maybe I have one question for Mr. Farhan because I want to know also. You use in your research by the ignition factor, right?
Yes.
And I want to know you consider about the type of the engine or not in your research because as I know that if you use another type of engines, so the treatment every engine is different for each other.
Yes, that's a very good question. So the European Emission Agency emission factor is based on their fuel, which in this case is marine diesel. So this is the type of fuel that will be used in this ship. So the reason why I use this, the general purpose of this is that most of the fishermen is middle to high school educated. So if we use tons of variable, it will be hard to teach them what this is about. So they need to make it as simple as possible. So a simple multiplication is needed.
Okay, thank you. Maybe I think enough because the time is also limit. So thank you for Mr. Farhan for your presentation. Please give applause to Mr. Farhan. I want to ask Mr. Martin, is it okay if we pause the meeting in here or we can move to one presenter again? Because your flag is 2 p.m., right? Yeah. Okay. Okay. Before you going, is it okay if we take a picture for a moment? Yeah. Yeah, it's okay. Yeah, maybe oh, okay. Yeah. Pak siapa? Mas.
Dari depan dari situ berdiri. From here, No. Okay. Oke, udah buka merah. 2, 1. Again. 1. Okay.
Okay, 3, 2, 1. Once again, 2, 1.
Okay, we can move on to the next presenter. The next presenter is Mr. Araya Aulia and Mr. Arif Fadila with title of Study on Design of Underwater Rescue Vessel for Indonesian Seas. For Mr. Araya. Is there Mr. Araya in here? No? Okay, I think we can skip for Mr. Araya and move on to the next presenter. That is Mr. Heni Siswanti, Miss Heni Siswanti, and Mr. Ahmad Zubaidi, Mr. Bambang Piseka, Mr. Rizky Chandra Arista, and Miss Vicky Kofi Azari. For Mrs. Heni Siswanti, please welcome.
Assalamualaikum warahmatullahi wabarakatuh. Thank you for the opportunity to present my paper. The title is Stifner Configuration Optimization on Tanker Sandwich Deck Structure using Finite Element Method. Okay, I'm sorry. Okay, the background is recently shipyard industry, shipping industry is have many challenges about designing ship structure with optimum weight, strength, and cost. The purpose is to increasing the payload, reducing fuel consumption, and reducing exhaust emission. Ship structure optimization usually involves variable plate and stiffener configuration to obtain optimum lightweight ship structure. One of them is using the lightweight material such as sandwich plate. Sandwich plate is consists of two-layer base plate adhesively bonded by thick core material. The picture is in front of you, and next. Usually in steel ship, sandwich structure is used to replace the conventional stiffened plate. Steel-based hybrid sandwich is consists of face plate made of steel. They are high density and high strength, and use the core polyurethane elastomeric with low density and low strength. The aim is thin plate face plate separated by thick core material is increase the moment of inertia of the cross-sectional area. So the stiffness and flexural strength of the plate increase significantly without increasing weight. This is called sandwich effect. Besides that, application of sandwich plate is to simplify the structural design by omitting or removing the secondary stiffener, like this one. This is a conventional stiffener plate. When the plate is replaced by sandwich plate, we can omitting some stiffener. The effect is it can reduce 5 until 9% structural weight. But the reducing of stiffener also can reducing strength and affect to the deflection. So if we use a sandwich structure, we have to check the strength by determine the proper configuration of stiffener, and the constraint we have to pay attention for the constraint is the strength and deflection. It have to meet the criteria from the rules. Nah, in this study, the aim is to determine the optimum stiffener configuration of the sandwich structure by using finite element method. With study case is a tanker deck structure of 3 cargo tank of a crude oil carrier. Next, the deck plate from the deck tanker structure is 11 millimeter solid plate is replaced with sandwich plate with the thickness configuration of 4 millimeter face plates and 15 millimeters fiberglass core material. The FRPU core material is fiberglass reinforced polyurethane elastomer. Is the novel core material developed by previous research team from Ship Construction Laboratory in Department of Naval Architecture ITS. It is consists of cast polyurethane reinforced with 7% of mass fiberglass. This core material is meet the LR and DNV criteria for sandwich core. The criteria is consists of density, hardness, elasticity, modulus, and etc. And the properties material is on the table. The face plate is steel, thickness 4 millimeters. The density and yang modulus is like that, and the core material is fiberglass reinforced polyurethane elastomer. Next, the sandwich plate is applied in the deck structure with the configuration of the table 2 is a structural part of stiffened plate structure. The stiffened plate structure, the plate is replaced with sandwich plate, and then the configuration of stiffener also we use a 5 model variation of configuration of configuration of stiffener. The model 1 sandwich A is the same configuration of stiffener, while sandwich B, C, D, and E is we remove secondary stiffener, the deck longitudinal with varied deck transfer spacing. Next. The strength assessment by using finite element method, the result is in the table 4. We can see that the sandwich model in P and C is the stress is above the permissible stress, and the sandwich model D and E is below the permissible stress. The permissible stress of the sandwich structure is 179.4 Newton per millimeter square. It is regarding the material factor K of 0.78. Then the normal strength half structure shields has the minimum nominal upper yield point of 235 Newton per millimeter per ski, same as the stiffened plate structure. Okay, next.
Sorry, Mr. Henny, I want to remind you that your time is only 2 minutes left.
Okay, yeah, thank you. Then the application sandwich plates reduce the stress concentration. The contour is show at the figure 5 for the stiffened plate. Figure 6 is stress contour of sandwich structure with deck longitudinal. And the figure 7 is stress concentration of the sandwich structure is reduced than stiffened plate model. Next. Besides the stress value, we also check the deformation that's associated with the structural stiffness, and the results show that sandwich A shows the most significant deformation reduction due to the replacing of solid plate with sandwich plate, and this the deck longitudinal is still used, but the model B, C, D, and E, the deformation decreased gradually in sandwich structure in inverse proportion to the deck transfer spacing. So more farther deck spacing, the deflection is more is bigger. It is also show the different deformation contour, and then the last is weight. The last is the weight of the structure that show that model A, the weight reduction is occur in 5.82%.
Sorry,
weight
Miss Henny, your time is already up.
Oh.
And maybe we can discuss in Q&A answer. Sorry.
Can I?
Okay, 1 minute. It's okay. 1
yes,
minute. 1 minute.
For conclusion. Yes. Okay, based on the conclusion is based on the analyze. Changing the design by changing configuration of application of sandwich plate can be choice for optimizing the weight of structure. However, the structural strength should be noticed beside the structural weight. In this tanker deck study, sandwich structure model A and D provide optimum structural weight reduction but not sacrifice structural strength. Sandwich structure model A significantly reduce stress deformation and weight. Meanwhile, the sandwich structure key provide a simplified design by omitting the secondary stiffener, although reduced stress, deformation, and structural weight are not significant but comply with the strength criteria. Whereas the design must be reviewed the transfer modulus to decrease the stress and meet the permissible stress criteria. Okay, thank you.
Thank you, Ms. Henny. Please give applause to Ms. Henny. So we move on to the Q&A discussion. Is there any Ms. Ati dulu, Pak.
Yeah, thank you for your presentation. Maybe back to sandwich material. This case is the thickness is 11 millimeter and changed by
23.
maybe page 2 or page 3 maybe. Yang this one. So for your case that 11 millimeter for thickness will be replaced by 4 millimeter and 4 millimeters, totally 8, and use polyurethane core
material,
about 15. And it will be applied into the deck, right? Yeah, okay. In the deck, if we use 11 millimeter, the gravity is, I say that 4.5 millimeter. If we use this, the gravity will be 11.5, right? 11.5. The original is 5.5 and this is 11.5. So the difference about 6 millimeter up the gravity based on the original one. Did you consider about the stability? Because this plate will be applied into the deck and it will be increasing for gravity will be up around 6 milli. And the original is 5.5 and then will be like twice. So I think you must consider about the ship stability. Because it's a very I think it's very big about the gravity. Or the other way that this material applied in the inner bottom maybe. Inner bottom will be the gravity still in bottom, but it will be problem in the space because there is a cargo and something. So how about your opinion and some? Thank you.
Actually, in this study, I'm not considering the stability, but maybe it is good advice for me to considering the stability for the next study. Yeah.
Because when I study about the question and the course, I also not and very important.
Yeah, maybe the hypothesis the gravity is up, is up, and it's affect to the GM of the the GM, especially for this is tanker. The GM is have to pay attention to the GM. Yeah. Okay. Thank you, Pak Adi.
It's all, sir, for your question.
Okay, thank you. The variation sandwich A to E with the same transfer profile.
Yes.
I want to know what your opinion if the change the profile with the same modules.
Actually, in this study, I just vary the deck transfer spacing without change the profile. If we use the different profile but the same modulus, I think we can use the same deck spacing, deck transfer spacing, but in the apa tuh, modulus, the modulus is the same, is okay, it's no problem.
Maybe you can try.
Yes, we
Okay,
we
thank
can
you.
try that.
Yeah.
But in this study, we just varied some transfer deck spacing. The actually in the different model, we use inside cell, we use different frame spacing and also different web frame spacing and also different deck side longitudinal. But the result is show that we use the result so that some of configuration is okay and some configuration is give stress is more than permissible stress like this. But the case study is specific, yeah, because we have to model the structure specifically. So I cannot say it generally like that. Yes.
Thank you.
Okay, thank you, Ms. Vivin, for your questions. Okay, one more question. Okay, okay.
Okay, this is a very good topic on the sandwich structures on the deck plate of tanker. Just looking at this model in here, is this full deck plate or is it only part of it?
It's only one side because it's symmetric and
Okay.
The finite element method is allowed to modeling just a half of structure. So I just modeling a half of structure, but it three cargo hold.
Okay, just not sure whether you have examined the applications of sandwich structures for the whole deck structures, because then you need to also calculate the hull bending moment and shear force. You know, if you are to apply the sandwich structure for the whole deck for the deck tanker, then by classification you also need to satisfy hull bending moment and hull shear force. Have you considered this, or are you thinking about it to extend into your future research? Because you know, it's maybe that your utilization ratio is below 1, but then you need to also look in the global load as well.
Yeah. Yes. This case study is preliminary study for my thesis dissertation.
Okay.
And I think the next study I will modeling it for whole decks.
Yeah, I mean if it does reduce the weight significantly, then in terms of application, then you need to check if this application is suitable or not, for the whole deck. Yeah, because this is only model case.
Yes, the model case.
Then
I assume that because in the center line there is longitudinal bulkhead, so
of course, yeah.
I model the 4/8 of deck is high constraint. So it welded to the side cell, welded to the
Yes. Yeah.
wellhead. Something like that.
Yeah, I mean, just an input for you if you want to pursue. I mean that you need to think that
Yeah, thank you.
Globally, yeah. Thanks.
Thank you. Bye.
Thank you, Mr. Rika, for your questions and suggestion. Thank you, Miss Henny, for your presentation. For audience, please give Mr. Henny applause.
Okay, thank you for the opportunity, suggestion and question, and thank you. Assalamualaikum warahmatullahi wabarakatuh.
Okay, I will give one opportunity to Mr. Arya Avlia and Mr. Arif Fadila for the paper title is Study on Design of Underwater Rescue Vessel for Indonesian Sea. Is there any Mr. Arif Fadila in here? Okay, it's welcome.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. Thank you for the change stand in here, and I want a presentation about study on design of underwater rescue vessel for Indonesian seas. Okay, next. First, we have a background. So far, there have been several submarine accidents whose crew could not be saved, such as San Juan, the Argentinian submarine which killed 44 of its crew. Of course, the Russian submarine which killed 189 of its crew. Komsomol, the Russian submarine which killed 42. Submarine are valuable asset owned by the Indonesian Navy. In 2019, Indonesia lost one of the Indonesian Navy submarine, namely the KRI Nanggala 402, which killed 53 of its crew. So Indonesia needs an underwater accident rescue ship to provide first aid when accident occurred at sea, including submarine. We have a purpose. First, obtain the appropriate dimension for the rescue vessel. Design underwater accident are needed. 2, get optimal design result based on size has been determined. 3, get result on the ship general arrangement image design. 4, know the stability of the ship and the resistance of the ship. 5, know the seakeeping value of the ship. 6, know the probability of water entering the deck. Next. We have a method of study on design of underwater rescue vessel for Indonesian seas. First, we use a parent design approach and trial and error method. The stability calculation, we use Krylov method. The resistance calculation, we use Holtrop method. and we use software, especially CAD, Microsoft, and SketchUp. Next. And we have a resistance of ship. We have a speed, velocity, power. Okay, next. We have an last plan, vessel, and general arrangement. Okay, next. And we have a seakeeping of ship. Okay, next. We have the stability of ship, condition 1. And we have stability of ship, condition 2. Okay, next. We have 2 stability of ship, condition 3. Next. And we have the stability of ship in condition 4. Okay, next. And we have a deck witness. The probability of water entering the deck at speed of 80 knots with a wave height of 5 meters is 9%. Criteria rules, general operability limiting criteria for ship, not Fox 9978, where the maximum value of probability of deck witness is 0.05 or 5%. Then if a ship is faced with wave as high as 5 meters, it is recommended that the ship go as fast as 15 knots. Okay, next. And we have a 3D room ship, like a toilet and room of mechanics. 3D. This is a 3D about the crane and life raft, lifeboat, and heli deck. Okay, next. And the conclusion, the result of resistance calculation using a software Microsoft with a speed of velocity 18 knots, the resistance value is obtained, and power using the Holtrop method. The magnitude of the resistance experienced by the ship with a maximum speed of 569.0 kN with power and require engine power 5,275 kilowatt. This ship can accommodate 15 victims and can sail for up to 14 days of rescue time. The probability of water entering the deck at speed of 18 knots with a wave height of 5 meters is 9%. The largest pitch movement is in the 0 degrees wave direction with an RMS value of 1.6 degrees. Meanwhile, for the biggest roll movement found in a wave direction of 90 degrees with an RMS value of 8.12 degrees, where this value does not meet the criteria for acceleration and roll. Whereas the maximum number of roll movement is 6 degrees, seakeeping rescue ship incoming criteria at wave height of 3.5 meters. Okay, next. Okay, thank you.
Yeah, thank you, Mr. Arif, for your presentation. I want directly move to the Q&A discussion. Okay, Mr. Ika first.
Okay, thank you. This is very interesting design. Can we go back to your general arrangement, please?
Okay.
Your general arrangement.
General arrangement, please.
The right. Okay. Now this objective is for underwater rescue. Yes.
Yes.
Did you consider rescuing until what is the maximum depth that you are considering in here? Is there any limitation? Because no, the question is because you have a little submarine in there. Yeah,
this
the little submarine.
Okay.
So do you also give do you also provide with the specification of that submarine? So that submarine is only capable of diving into, I don't know, maybe only 10 or 20 meters water depth, or do you also consider that? Or is it just put it there? Do you also consider that?
I'm sorry. What's this?
Yeah, that's the mini submarine, isn't it?
This is.
Yeah.
Is
mini submarine. What is that? Submarine?
We can use a ROV and we can control with the controlling room in ship.
Yeah.
But
for example, if you are rescuing KRI Nanggala,
yes,
using ROV, how many person you can carry?
Okay.
Then that will be problematic because you got 15 patient on board, but your submarine is very small. So you need to consider the distance, the depth of submersion.
Yes.
And then if you can only carry 1 or 2, then you need to go back and forth 7 times. So that's one. Number 2, in this design, do you also consider, because for example, is the submarine is accident is in the middle of the ocean, then you need to be stationed at that position, yeah?
Yes. In stability?
It's not stability.
It's not.
You need to be directly above the submarine, for example. But you need to keep station on that.
Yes.
Is it? Do you have any dynamic positioning system installed, or is there any temporary anchor, for example? Because you cannot rescue if you stop the engine, then it will be drift. Also, if you deploy your anchor, if you do not know the water depth, anchor may not be sufficient. So the good thing is that if you got dynamic positioning, but in your design, have you considered that? So
okay.
Yeah, I mean if it's okay if you have not considered that, but that should be put into your consideration, because firstly is the capacity of your mini submarine. Secondly, there is a station keeping, what we call it, meaning that you need to be stationed in there, because otherwise your vessel will be drifted away from the location, isn't it?
Yeah. First question. We can rescue the in submarine like KRI Nanggala.
Yeah.
We can. What's the name?
It's okay. It's just part of your design stage. You just provide with design of the vessel.
Mm-hmm.
Those mini submarine could be like a third party, what's it called? Third party rescue or salvage operation or whatever. But you have provided with the designs of the of this facility. But also if you have not considered, you need to put dynamic positioning in there, as I said, because if not, then KRI Nanggala down here, then you should be drifting away. That hypothetical situation, yeah.
First, we use an anchor
maybe if we can reach the seabed, we can the anchoring,
Yeah.
or we can use other
you need to use it. You need to use a dynamic positioning. Yeah.
positioning.
Because if you go anywhere in Indonesia, the water depth is the water depth varies. So you in a certain depth, your anchor chain may not be sufficient to until when you deploy, it may not reach the seabed. Just for example. So I think in your design you need to add dynamic positioning in here.
Okay.
Yeah, it's just a suggestion. Yeah.
Suggestion.
Okay, yeah.
Okay.
Thank you.
Yeah, thank you, Mr. Rika, for your question and also suggestion. Because our time is already over. Maybe we can move to the next presentation. And thank you, Mr. Arif, for your presentation. Please give his applause.
Thank you for attention. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Okay, so we can move to the next presenter. That is Mr. RINA Rahma Pangestu, Mr. Fajri Asri Raihan, Mr. Arya Koirullah Akbar, and Mr. Bima Anugrah Putra, with title of Study on Drag Reduction of Petrol Boot using combination of trim tab and interceptor. And the presenter is Mr. Arya Koirullah. Time is yours. Okay, I will to remind all participants that we only have 10 minutes for the presentation and also 10 minutes for the section. So I hope you can make it as soon as possible.
Tes. Assalamualaikum warahmatullahi wabarakatuh. Okay, first let me introduce myself. My name is Arya Khairul Akbar. Today here I am the representative of my team. This is my team, Dr. Fajri, RINA Rahma, Arya Khairul Akbar, and Bima Anugrah Putra. And I'm from 7th semester UPNVJ Jakarta student. Today I will presenting to you my study. Okay. The title is Study on Drag Reduction of Patrol Boat using combination of trim tab and interceptor. Yes. Okay, the first introduction. As we all know about, Indonesia is the largest archipelago country in the world. And because of that, Indonesia have wide sea. And because of that, we Indonesia we have a potential to be the largest maritime country in the world. And to achieve that, we need to focus on one aspect. That aspect is the security of the border of the Sea of Indonesia. And security aspect, we can use a fast patrol boats to determine our border at the sea. Okay, bisa di next. Okay, fast patrol boats. As the name fast patrol boats, it has a high speed. Because of that high speed, fast patrol boats can create a vast amount of drag. The one way to reduce the drag is to change the shape of the hull, or we add some appendages to the stern of the hull of the ship, such as interceptor and trim tab. Okay, ship resistance can be written as RT, or total resistance total equals to half of coefficient of the total resistance itself, density the water times water density times weighted surface area and times velocity squared. Okay, shape analysis. In this study, we use the model of KPC 60 that was built at Caputra Mitra Sejati Shipyard at Cilegon, Banten, Indonesia. Was built in 2020 and was launched in 2022. And this is the lines plan of the KPC 60, and the other is main dimension of the KPC 60. Okay, shape analysis. In this study, we have 4 kind of variation that has for each of its sub variation. The first variation is the variation of the velocity. We have 7.7, 10.3, 12.9, and 15.4. The second variation is the variation of the Froude number. It's 0.3, 0.4, 0.5, and 0.6. The last variation is the model of the ship. The first we have A, it's KPC 60 model without interceptor or trim tab. B1, it model KPC 60 with trim tab. C, KPC 60 with interceptor, and D, the combination of trim tab and interceptors. Okay, result and discussion. We have 5 points of the results resistance component analysis. There are total resistance, viscosity resistance, friction resistance, wave resistance, and appendages resistance. Okay. Now based on the graph, we can see the green line, it's the KPC 60 model with the combination of trim tab and interceptor. It shows the KPC 60 with combination has the lowest coefficient in total coefficient, viscosity, and wave coefficient. So it is proof that trim tab and interceptor can reduce the drag. It's with an average of 27% of the resistance decrease value. Okay, the other one is appendage coefficient and friction coefficient. Why the appendages coefficient is only have 2 lines? It is because the green line, the KPC 60 interceptor, trim tab, and combination, it has the same value because of the equation of the formula is 1 plus K is a form of a coefficient. So it has the same value. And why the friction coefficient is only 1 line? Because the length of the boat is all the same. So the value of the equation and formula is all the same for combination of the models. And drag reduction, it was found that the highest percentage of 35.1% drag reduction occurred at 0.5 Froude number. This phenomenon was caused by the effect of the combination of trim tab and interceptor. So it was proved by this graph that interceptor and trim tab can reduce drag resistance. And this is the wave contour. You can see the model with the trim tab and interceptor have more friendly wave than the model without the trim tab and interceptor at the top, and with the trim tab and interceptor is at the bottom. It is based on the picture. It is proof that trim tabs and interceptors can reduce wave elevation in significant amount. And the conclusion, in this study, Vice Patrol Boat 60 or KPC 60 is investigated using Maxwell's model advance and to make a fine marine software, conclude that KPC 60 without using an interceptor and trim tab has the highest wave in elevation. In addition, the wave elevation and height resistance value will cause the ship to experience trim. The hull using the interceptor and trim depth has the lowest wave elevation compared to other hulls model. So it is proof that the interceptor and trim depth can reduce the resistance with 35.1% at float number 0.5. Okay, that's from me. Thank you for attention. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you. Thank you, Mr. Arya, for your presentation. Let's move on to the Q&A discussion. Is there any question, Pak Ketut?
Thank you. It is interesting work, yeah, by you and your team. Yes, I agree with you. Using interceptor can reduce resistance. But could you show again the picture actually as a combination when there is in trim tab or interceptor and when it is not available? So we can see again that these appendages work well. Can you show the visualization? Yes. So the upper part is without.
Yes.
And the below is with.
Yes.
Okay. The below one actually you put both directly, the trim tab and interceptor, yeah, not one by one.
Yes.
And you find that the optimum is at float number 0.5. You
Yeah,
said in
0.5.
conclusion.
Yeah.
Actually, what happened actually at 0.5? Why 0.5? Not 0.6 or 0.4?
Well, this is because I'm focused on the equation, not this one of the wave contour. It's just some appendages detail to support support our paper. But why we choose the 0.5? Because it based on the equation.
But actually from this visualization, it is clear that 0.5 is optimum. You can see from the color of the picture, the spread of the wave pattern. Yeah, 0.5 is optimum.
Oh yeah, yes.
Yes. And perhaps you need to show, actually there's another way to show the visualization using the factor plot, what happened with the flow movement. Yes,
Oh, okay.
along that body when interceptor and trim tab is occupied.
Okay, sir.
And then you can give the further or detailed explanation, because you have done the simulation, you have done the calculation, but you need to explain what happened physically there.
Oh, okay. I will
Yes.
make a revision in my paper.
Okay, thank you for the good job.
Okay, thank you, sir.
Thank you, Prof. Ketut, for your question and suggestions. Okay, Prof.
Okay, just in addition to Prof. Ikap just now, float number 0.5 is associated with what speed? Float number 0.5. What is the speed? What's the speed?
In knot.
Yes, in knot.
What speed?
What speed?
In knots.
Yes, in knot.
Yeah.
Yeah, what is the speed? That 0.5 float number, yes?
Yes.
So what is the speed? Float number, is when you do the simulation, you have float number 0.5.
Oh, it's the wave speed.
No. I mean that float number is the ship float number, isn't it? 0.5, yes?
Yes, yes.
So that float number in actual related to what speed of the vessel?
It's that fast patrol boats.
Yeah. What speed? What speed? What speed?
You mentioned
7.7
to 15.5.
It's around 20 until 25 knots.
Okay. 20 or 25 knot. Is
Yeah.
So your What is it? Is this FP? Is this fast patrol boat 60? Is it?
KPC
Huh?
60.
KPC 60.
60.
So in a KPC 60, do you know the specification of KPC 60? The surface speed would be what, 60 knot, or what is the surface speed? The real surface speed of KPC 60 is what? What is it? I'm just want to know. Maybe you have put specification in there. Is there any data about KPC 60?
What Mas?
Yeah, maybe it's already there. I saw the lines plan. Is it? There's a
Yeah, in beside of the lights plan.
okay, this one. Okay, top speed if 25 knot. Yes.
Yes.
So what fruit number is 25 knot? 25 knot. What is the fruit number?
Mas. Lanjutin.
Okay,
There's
so
variation.
there is a variation of fruit number 0.3, 0.4, 0.5, and 0.6. Yes.
Yes.
So 20. What was that again? 24 knot. 24 knot is what fruit number? Is it 24 knot falls within what fruit number? You know, the reason my question is that because you said that the optimum is 0.5 knot. Yes.
Yes.
But I wonder, is that 0.5 knot equal to 24? I wonder if the fruit number 0.5 equal 24 knot.
Oh.
You see what I mean?
Yeah.
Because if not, then the KPC will not be the optimum one.
Oh, yes. I get it.
You see what I mean?
I get it.
Yeah. So that fruit number 0.5, you said that it is the optimum. Is that associated with 24 knot?
Oh, yes.
It is associated with 24 knot.
Yeah.
You sure?
Yeah. Yes.
Okay. Okay. Yeah.
Oh, okay, sir. I will make revision.
Because we don't know when you said that is the optimal, or that's the optimal, then there is a question whether the speed, whether that 0.5 is actually at the 25 knot speed. Otherwise, you know, it may not be on the optimum.
Yeah. I get it.
Did you get the question? Yeah.
Yes, I get it.
Yes. But
Thank you.
I mean, it's good, very good. Yeah, good job.
Thank you, sir.
Thanks. Thank you.
Thank you, Mr. Ika, for your suggestion. Maybe I will give one more chance for the question. Is there any question? Okay, if there is no question and the limit time, thank you, Mr. Arya, for your presentation. Please give Mr. Arya applause.
Thank you.
And we can move on to the next presenter. That is Miss Amalia Ika Wulandari, Mr. Iketut Arya Priyautama, and Mr. Aris Sulisetiono, with paper title is GFD Analysis into the Resistant Characteristic of Warship Catamaran in Calm Water and in Waves. For Mrs. Amalia Ika. Okay.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And good afternoon, everyone. Today I will present our research with title Analysis of CFD Simulation Towards the Resistant Characteristic of Warship Catamaran in Calm Water and in Wave. With the authors are Amalia Ika Wulandari, Prof. Aris Sulisetiono, and Prof. Iketut Arya Priyautama. We are from Department of Naval Architect, Institut Teknologi Sepuluh Nopember, Surabaya. Okay. In this slide, were organized into the focus research, introduction, methodology, result discussion, conclusion, and recommendation for the next research. Next. The focus for this research, this study focus on investigating and discussing the resistant characteristic of catamaran warship in calm water and in wave using computational fluid dynamic or CFD simulation. And the next slide, the introduction. The development of catamaran was not only as a passenger, but was also developed as a warship. And one of the Indonesian warship is a tank boat type, having a catamaran multi-hull operated in high speed is highly considered. And catamaran exhibit reduced power demand in comparison to monohull ship of equivalent length in order to achieve the same velocity. However, catamarans possess a diminished payload capacity when compared to monohull ship. And then this paper will investigate and discusses the resistant characteristic of catamaran in calm water and in wave utilizing computational fluid dynamic or CFD simulation. Next. Okay. In methodology, there are 5 points. The first point is about warship catamaran. The second point is numerical setup. The third point is computational fluid model. And the fourth point is grid independent study. And the 5th point is resistance of catamaran. Next. This is study focuses on a warship catamaran measuring 16.52 meter in length, 6.649 meter in breadth, and 1.184 meter in depth. The catamaran is capable of reaching a speed of 40 knots. And the simulation is conducted using numerical methods, specifically by varying the speed or float numbers within the range of 0.3 to 0.7 and consider separation to length or S per L ratio of 0.2. And the ship's hull exhibit an asymmetrical structure as shown in the figure, and then with the one side being flat on the inside. The asymmetrical configuration have the potential to minimize hydrodynamic interference between hulls, reduce spray impact on the platform underside, and offer a more convenient setup for hydrofoil installation. Next. And then numerical setup. And this study examine and analyzes the resistant properties of a catamaran in both still water and wave condition, draw the utilization of computational fluid dynamic simulation. And the technology of CFD simulation is advancing rapidly and has emerged as a crucial approach for predicting the resistance of semi-planing boats. And then for the equation, for the numerical setup using the equation 1 for the continuity equation, then second one is the momentum equation. Okay, this is the computational model for this picture. For this figure, show the auto refinement the model in the CFD modeling. And then the computational domain is divided into grid, and the breakdown domains grid is size is often increased, and the grids are concentrated around the hull in order to decrease the grids, and there will be optimizing the computational time. Next, please. Next is grid independent study. A grid independent study is a crucial step in CFD simulation to verify that the solution of a CFD problem remains unaffected by change in grid size. And then the CFD simulation demonstrated that the cell count of 2.9 million exhibit a resistance disparity of around 1.15% compared to the prior cell count, less than 2% as stated in reference. And then therefore, the grid independence has been achieved with total of 2.9 million. Next. Okay, this is the equation we use to calculate the resistance of catamaran. There are 5 equations can use to calculate of the coefficient total of catamaran, coefficient friction, coefficient wave, and then viscous coefficient. Next. Okay. This is the result of discussion for catamaran, and then this is the result from CFD. From the CFD software was employed to compute the overall resistance of a three-dimensional ship model at 7 various distance with hull spacing ratio as per L of 0.2 and plot number range of 0.3 to 0.7. And the color pattern represent the fluctuation in wave height surrounding the catamaran. This figure show the contour of wave elevation in calm water in plot number with the highest value wave elevation of 1.8 meter at the bow of the boat hulls. After figure A, this is figure 7B. This is illustrated to the contour wave elevation in calm water 2, but the wave elevation in plot number 0.4 is of 2 meter of the bow. Next. Same them figure 7A and 7B. 7C show the wave elevation, but the highest value for the plot number 0.5 is around 2.0 meter. This is the figure 7D. So this is the figure show in wave elevation in plot number 0.6, and the wave elevation height is 2.5 meter. Next. The last from in calm water at plot number 0.7, and then this is the highest value is of 3 meter at the bow of hulls. And then the next slide. This is show the next slide show the contour of catamaran in waves. That the in waves range for plot number from 0.7 to 0.3 to 0.7, and then a wave height of 1 meter from the bow are shown in figure 8A to 8E, and then in 8E, this is the figure 8E explain the wave elevation contour at plot number 0.3, and then the 0.3 wave elevation show in 1.6 meter. Okay, same with figure 8A. The 8B explained in wave elevation contour at plot number 0.4, and then this is the highest value for wave elevation height. This is around 1.6 meter. Next. Okay, this is figure 8C. 8C, this is at plot number 0.5, and then the value from wave elevation.
I'm sorry, Ms. Ika, for your disrupt you. I want to remind you that your time is 2 minutes left.
Go to conclusion. Okay, we'll go to conclusion. Okay, the conclusion is about CFD has validated the resistant component of warship catamaran quite, and then the results show that the speed differences of the catamaran strongly affect the resistant characteristic due to the total resistance in calm water and in wave condition between the interaction of the hulls. And then the CFD calculation result indicate a consistent increase from 0.3 to 0.5, and then the highest value for the total resistance coefficient or CT in calm water is 0.5 with a value 17.45 times 10 in the power of -3. And then the highest value of the total resistance coefficient in waves at plot number 0.5 with a value of 19.31 times 10 in the power of -3. Thank you.
Thank you, Miss Ika, for your presentation. Is there any question from audience? Okay, Pak.
Thank you. Great presentation. I some question. First question is I show in your slide for future research. You use experiment for validated. Yes. And second question, in your slide show in actual case, and what parameter will you validated with next starting with experiment? Okay, thank you.
Thank you, sir, for your nice question. And then I plan for future research experiment we will do in the model scale. But in this presentation, I show in the full scale. After this, after I do experiment, we'll do in model scale, and then I do simulation for the model scale too. Thank you.
Is answering your question, sir. Okay. I will give another chance to audience. Is there any questions? Okay, Pak.
Okay, thank you. Of course, Ms. Amalia already show a good presentation. Unfortunately, the time is not enough for her to explain until everything. But Ms. Amalia, I'm interested in the correlation between the speed of the ship and the resistance itself, because you use the variation of Froude number. And of course, we know that it's varied in this at this velocity. So can you explain the correlation between it, velocity and resistance of the ship? Thank you.
Thank you, sir, for your question. And then the relation between velocity and resistance is the quadratic relationship expressed in the form of the resistance. And then the quadratic relationship emphasis to substantial impact. This is correct.
Is that answering question, sir?
But in your study, did it show that the difference between speed really illustrate the difference, maybe in the chart or in the wave elevation, because you already showed the pictures, and of course there are different. We would like to know if what is the impact of the velocity to the resistance.
Okay. If we see the contour of this result, we see the of the contour if they are in the Froude number 0.3 and the wave or the contour is maybe become the green color or the blue color, but if the speed increase, the color is become to be green or to be yellow or red.
Okay. Thank you for the answer.
Thank you for your questions. Maybe we have one question from the online chat. Can you explain the significant result with different S over L?
Thank you, Mrs. Dian, for your question. But for this research, we don't consider to know the result to variation the different S per L. But the next study we will do for the different S per L.
Okay. Is answering your question, Ms. Dian Purnamasari? I think enough, because we already have a limit over time. And thank you, Ms. Amalia Ika, for your presentation. Please give him to.
Okay. Thank you, Mr. Moderator.
I want to ask to the audience, for the committee will deliver some coffee breaks, but if we have some coffee break, so it make the finishing our agenda is longer. So I will give you coffee breather. Okay, coffee breather. Okay, maybe coffee break for 15 minutes. It's okay. Yeah. We can come back in this room maybe 14:40. Okay, thank you.
Baru Mister DIY lagi nih.
Tentang tadi, saya udah bilang. Tentang ini nggak? Okay. Okay, for the participant still in outside, please go to the inner room because we will continue our meeting. Benar, Pak. Okay, I think we can continue our presentations. And the next presenter is Mr. Mikhail Arnold Wonata and Mr. Arif Fadila with paper title is Design of Pentamaran Ferry Ship for Jakarta to Balikpapan route. For Mr. Arif Fadila, is there Mr. Arif Fadila in here? Maybe Mr. Fadila is still in outside. Mr. Farid. Still in.
Yes, Mr. Mikhail Arnold Wonata. Okay, I think it's better to move to paper 28.
Okay.
Mr. Arif Budianto. Are you still there?
Yes, yes. Okay, I'm online.
Okay, please, Mr. Arianto, you can share your screen. And I will remind you that we only 10 minutes for presentation and for discussion, 10 minutes. Thank you.
Okay, thank you. Wait a minute, I will share my screen. Okay, can you see my screen?
Yes, sure.
Okay, good afternoon to all audience. That this is my last paper that submit to ICSOT 2023. Yeah, in this opportunity, I would like to introduce our research with the title Evaluation of Carbon Emission from Loading and Unloading Activities in Container Port. That this work is actually work together with our colleagues in UI and our professor in Kyushu University. The outline of this presentation will be consist of the introduction that will research background and research objective, and the methodology is the energy consumption and carbon emission, and result and discussion, and last is conclusion. Now I will move to the research background of this research that as we know that the National Maritime Organization that have been the target to reduce carbon emission by 20 and 40, and all sector in maritime industry need to concern about the carbon emission to reduce the greenhouse gas emission. So in this from this background, so we need to measure the carbon emission that emit in ships and also in the port. So the objective of this paper actually to estimate the carbon emission particularly in container terminal. The contribution is this paper is to provide an overview of emission mapping in container port, and will be direct us to how to reduce the carbon emission, particularly in container port. So the methodology that we use for the estimation of carbon emission, actually what we call with the bottom-up calculation. So from the bottom to we summarize into up in the operational area activities in container terminal. So which the bottom-up calculation, actually we based on the fuel consumption and also activity from the container terminal. So the calculation of energy consumption actually carry out from the loading and loading operational activities, and the input variable that we use is the throughput, and then process of moving containers, and then transportation modality and terminal layout. And then we can compare between the activities and then the fuel consumption based on our calculation. So we need to know how many types or how many equipment that actually the port that we measure. So we classify into three container handling equipment. The first is the truck that consists with the terminal truck or internal truck, and then also reach stacker and top loader. And then for the quayside crane, actually there are two types of the quayside crane. The first is quayside container crane and also ship to shore crane. And also the yard crane, actually there are two also commonly used rubber tire gantry crane, also automatic stepping crane. For this paper, actually we have a case study that we use for the calculation. We use some terminal in Indonesia that with the capacity is up to 9,000 TEUs per year, and then that the terminal actually has a jetty about 8,000 meters square, and then the location between the stacking area and then the berth is there are some different location that connected with the bridges. So from this case study, we calculate using the bottom-up method that actually in the container terminal, actually there are two types of equipment that based on the energy source. The first is from the electrical and also from the diesel. Actually from the electrical, that the type of equipment consists of quay crane, ship to shore, and automatic steering crane. And also for the diesel, there are some straddle carrier, terminal tractor, something like that. And then we need to define the variable consumption that we define from the data from the equipment types, and also from the engine specification and something like that. So we calculate for 1 year carbon emission, because we need to input throughput, modality, transshipment process, and also terminal layout. And actually there are two type of container movement. The first that we call with the vertical movement, that usually using the container gantry crane, also ship to shore crane, and also horizontal movement. Actually that horizontal movement, they are from the container truck, and also from the ship to shore crane, and also from the gantry crane. And from the movement, we try using the distance travel from equipment. So we validate from the data record from the port, and also we try to estimate using the Manhattan distance that we try from the point A to point B with the far distance. And then, so this is the result for our research. So this figure actually shows the distribution of energy consumption. That from this figure that we can see that quasi container crane actually have a higher energy consumption compared with the terminal truck and rubber tire gantry crane. But we must notice that the quasi container crane in this case usually using diesel for the movement. And then also we try to distribute of the energy consumption between the loading and unloading, because in the port actually there are two activities, loading and unloading. So for the distribution, actually almost from the loading and unloading is almost same, but the difference is in the terminal truck, that the truck is related with the location that the container will be placed or something like that. And also we try calculate the CO2 emission in container based on this case study. Actually, the contribution of carbon emission per equipment at this container terminal, the quake crane, rubber tire gantry crane, and transfer crane, 54% for the quake crane, and then 26% for the rubber tire gantry crane, and then terminal truck is 20%. And the CO carbon emission per year is almost 600 ton per year, and higher for the container terminal. And for the sum of CO2 emission contribution, then divided into annual container throughput. So the container emission for the TEUs for this case study, actually we calculate at the 13.7 kilogram per TEUs. So we can imagine that the container movement in the container port, actually they contribute of the carbon emission about 13 kilogram per TEUs. So now I will move to the conclusion that the first, that estimation of CO2 emission has been carried out using bottom-up method, and then the evaluation show that the largest emission contribute from the rubber tire gantry crane, and I'm sorry, from the largest emission is come from the quasi container crane, and then rubber tire gantry crane, and then transfer truck. And CO2 emission per TEUs for this case study is 13.7 kilogram. Actually, this value is more higher than other container port that we have studied previous research. And for the future work, we try to make some emission reduction strategy that that we want to comply with the IMO target. So there are some research that we have to collaborate for the future work. That's all our presentation. Thank you very much for your attention. If you have any questions, any suggestion, we are very welcome.
Okay, thank you, Mr. Arif, for your presentations. So I would like to give the opportunity. Okay, Mr. Ika.
Okay, thank you very much, Dr. Arif Budianto. Can you bring up again on the objective, research objective? Yeah.
Yeah.
Okay, because in the conclusions you mentioning that this is just to support target IMO. So as far as I know, IMO targets of reducing greenhouse gases is only applicable for trading vessel, as in MARPOL 6. So when you saying that reduction emissions on the terminal, who will benefit in on this report, on this monitoring report and all? So for example, if you say that Port A has carbon emissions of this ton per year, what would be the standard to validate that, okay, this is low, and then who would benefit? Because I mean, who is the regulators that you are going to satisfy? I mean, as I said, IMO Marpol 6 is for trading vessel, as far as I know, but not for port.
Yeah, thank you, Professor. Actually, the regulatory for Indonesian side now is Ministry of Transportation under the Sea Transportation Directorate. So actually now currently we are on progress on the standard for the green port that will be certified by the national owned company, for example, BKI, Skovindo, and then some Surveyor Indonesia, that they will have some measurement method to certify that the container port is green port or not. And on the other hand, that I'm not mistaken, that IMO included the port and also trading ship, yeah, not only for the ships but the also in the port. That currently there's some progress from the green port.
Okay, can you pointing out which regulation on the IMO that has the standard for IMO?
Yeah, actually, I'm not sure from the number, but still in under Marpol, maybe. But there are some the IMO actually there are some clear target and also mitigation that have been set by IMO that included for the port.
Okay, okay. Thank you. Thanks.
Thank you, Aika. Okay, go to Mr. Ketut.
Okay, thank you, Pak Arif Budianto. It is a very nice work. Continue what Pak Ika Prasyawan asked. Usually the standard for the emission applied for vessel operating at sea. But I agree with you. So this issue should be continued with the port facility. Although you are not so sure which part of the IMO regulation says that. But it is very interesting actually to know, one actually, do you validate your calculation 13.7 kilogram per TEU is correct?
Yeah.
Yes.
Okay. Yeah. Actually, we have some.
Okay. Wait a minute, Pak Arif. This is the first question because it could be lower or maybe bigger, but I would like to know how correct it is. Second, if it is correct, is that any roughly standard if the 13.7 actually below or above the certain criteria? So and then you can say this is an alert for Indonesia to consider this. Thank you, Pak Arif.
Yeah, the first about the validation first that we have been carried out, that the validation actually we try to compare with the emission factor that sum by the energy consumption. Actually, this result actually for the estimation based on the what we call with bottom up method, that we some assumption and then the data input only the throughput and then the location of the container and then layout of the layout of the container port. And also we validate the result with the power consumption that recorded by the container port. So we compare that the result is a good agreement, but maybe I am not sure in this presentation that the first validation. And then the second one, that we also have some good collaboration with our partner in Japan. And regarding the second question, until now we don't have any standard how many emission per TEU, but by using this standard, actually we have been evaluated for the 4 container port in Indonesia and then 2 container port in Japan, in Hakata and also Tokyo. Yeah, actually for this case with the same method, for this case, actually, we have a higher that compare with the port in Japan. But in other cases, in that we have been measured in around Jakarta, that we have some new container port, that the number is almost similar with the Japanese port. But yeah, until now we don't have any standard for the how minimum or how much the emission kilogram per TEUs. But because this very depend on the container layout and then efficiency of the container and something so on. But on the other hand, because Indonesian government have been ratified from the Paris Agreement, also Glasgow Agreement, now the port actually they want to reduce their CO2 emission. So this number actually will become the baseline. That in this case now is maybe 13.4.7 kilogram per TEUs. So for the next 5 years, what's the plan for this port, and how the implementation of the plan for to reduce the carbon emission in the port? So that's the main yeah, this is some other goal for this energy mapping or emission mapping for this port.
Okay, thank you, Pak Arif.
Thank you, Atot, for your questions. And is there any questions in here? And I think there is no question also in the room chats. So I think it's enough for your turn, Mr. Arif Budianto. Thank you for your presentation. Please give
Thank you very much
to Mr. Arif Budianto.
Yeah, thank you.
Okay, we going to the next presenter. I would like to give the one opportunity to Mr. Arif Fadila. Is there any Mr. Arif Fadila in here? Mr. Arif Fadila. Okay, please come here to present your paper about design of Pentamaran ferry ship for Jakarta to Balikpapan route.
Assalamualaikum warahmatullahi wabarakatuh. Good evening, everyone. I would like to talk about design of a crossing ship with Pentamaran Hull, Jakarta Balikpapan road. Background from Design of Pentamaran Ferry Ship for Jakarta Balikpapan Road. Background, the move of the state capital to East Kalimantan province will lead to a massive displacement of the population from Jakarta. So we need a mode of transportation to transport goods, passengers, and vehicle. One form to effort that can be made is creation of the crossing vessel with the Pentamaran hull, which is the vessel designed to carry passenger and vehicle on high-speed Jakarta route so that the time required to reach destination can be faster compared to a general vessel. Ship fishing. Ship fishing route Jakarta to Balikpapan, 886 nautical miles, estimate day, 1 day per trip with the average speed of 30 knots. Purpose, obtain the appropriate size for the Pentamaran crossing ship on the Jakarta Balikpapan road. Optimal result for a line plan and general arrangement for a Pentamaran crossing ship. A good comparison of the stability Pentamaran crossing vessel with the monohull crossing vessel in accordance with the applicable criteria. A comparison of resistance on Pentamaran crossing vessel with the monohull crossing vessel. Seeking comparison result between Pentamaran crossing vessel and the monohull crossing vessel and get the result of the witness calculation on Pentamaran crossing vessel. Next. Methodology, design Pentamaran hull with the comparison method, the resistance of Pentamaran ship with the hull drop method on the Maxsurf apps, and the stability of the Pentamaran ship with the Kirchhoff method. Design Pentamaran hull with the comparison ship. That's the ship of KM Jumbo, name of ship type-nya Ferry Roro, LOA 68 meters, breadth 15 meters, height 3.5 meters, draft 2.4 meters, speed 12 knots. That's the line span Pentamaran type A. Next. Line span Pentamaran type B. Result resistance comparison. KM Jumbo have the resistance 100 to 25 kilonewton. Pentamaran A 114 and Pentamaran B 136. Next. That's the result of stability Pentamaran A, B, and KM Jumbo. Next. That's the result skipping Pentamaran A, B, and KM Jumbo. Conclusion, in the result of comparative analysis between KM Jumbo for the KM Jumbo to Pentamaran type A and B crossing ship in the mindset result for the Pentamaran type A with LOA dimension LOA, LWL, B, and T main hull 98, LWL 95, B 88, 8.8, 37, draft 3, height 8 meters. In the result of comparative analysis between KM Jumbo and the Pentamaran type A and B crossing ship, the resistant value result we found for KM Jumbo resistant 125 Pentamaran type A 114, Pentamaran type B 136. And the result of the comparison analysis between KM Jumbo and the Pentamaran type A and B crossing ship seakeeping value result we found as follow according to criteria for acceleration and roll at KM Jumbo at wave height 2.5 meters for roll movement. The RMS value is the 7.98 degrees. Seakeeping meet the criteria at a wave height of the 1 meters. Pentamaran A at the wave height of 3 meters, both for pitch and roll movement. It's meet the criteria with a RMS value of 3.88 degrees. And the Pentamaran type B, wave height of 3 meters, pitch and roll movement are not included in the criteria. Seakeeping meet the criteria at a wave height of the 0.5 meters. Thank you. That's the 3D type A Pentamaran. Thank you. Thank you.
Thank you for the presentation from Mr. Mikhail and Mr. Arif. Is there any? Okay, please give applause to Mr. Okay, Mr. Ika, please.
Yeah, this is very innovative research. Very good example of how you capture opportunity. There will be like route between Jakarta and Balikpapan. Can we just a little bit of clarification? Can we go to the beginning of the slide? Not this one. Okay, this one. So estimated time 1 day trip, average speed 30 knot, 886 nautical mile. So 1 day trip meaning how many hours in your calculation? Is that because estimated time 1 day trip, yes? So with average speed 30 knot, distance 886 nautical miles, how many hours is that? You know, like more than not is miles per hour, is it? No. So that would be like wait a minute, let me open my huh? Yeah, how many I'm just wondering. Hang on a second. I'll just try to find. I'll open my calculator.
Oke. Oke, terima kasih. Halo. Estimate in terms 1 day, 1 trip, and
so it's 6 divided by 30, isn't it? So 29 hours, 28 hours. Correct or not?
No.
Huh? Okay.
No.
Correct or wrong?
No, up to 20 hours in once.
20 hours.
Time, yeah, 20 hours.
20 hours. Okay, 20 hours compared to the Jumbo 9. What is the route of Jumbo 9? Jumbo 9, you make a comparison with KMP Jumbo 9, yes? So Jumbo 9 is from where to where? What is the surface of Jumbo 9? From where to where? I mean, is it also from Jakarta to Balikpapan? Jumbo 9? Yes.
Jumbo 9 and Jakarta and Balikpapan.
Jakarta and Balikpapan.
And same.
The same. So, you know, with the average speed of 30 knots, did you also consider how much fuel that they're going to consume? And then if we go, can we go back to the general arrangement? General arrangement of there is a general arrangement, yes, general arrangement.
Next.
The general arrangement. No, I think sorry, not this one. I think on the last page there is a 3D representation.
In the
No,
last,
this one.
in the last,
I think I
in the
saw
last
the
slide.
I saw 3D. Yeah, this one here. So I'm just wondering, for 20 hours, where do you put your fuel tank? Because that would be very big fuel consumption. If you use diesel oil, that would be very big. So, but this is Pentamaran, which is very slim hull. So whether that will be will be sufficient to put fuel tank in there. I mean, that maybe you need to consider that. Secondly, second question is that when you do the seakeeping, you do 3 meter wave height, yes? 3 meter wave height, seakeeping, in the seakeeping. Okay, can we go back again to the the first slide, the first page? Again? Yeah, this one. Okay. So you see, no, not this one.
Previous one.
Yeah, okay. Yeah. You see that the this is open sea in there, in south of Kalimantan, in south of, okay, let's say in south of Banjarbaru. Do you think that the wave height there is 3 meter? I mean that 3 meter wave in your seakeeping check, yes? You take it from what data? You use 3 meter, yes? In the seakeeping you use 3 meter wave, yeah? But that 3 meter is based on which wave data. So then you need to consider that the ocean wave in that particular area might be more than 3 meter in there, isn't it? Just for your consideration, so that that you also need to consider seakeeping behaviors for wave at that particular area, and then looking at your deck arrangement, there is a lot of cars and trucks in there. Then you also need to consider how to secure that vehicle, because this is 886 nautical mile, 20 hours journey. Then if it is an open deck, your car will be like sprayed with the salt waters and all that. It might get inflict some sort of corrosions or whatever. So there is some consideration on that, because I saw the general arrangement is like an open deck, isn't it? Open on your 3D picture. Or maybe I'm looking at the wrong. This one, does it mean this open, or is it only a deck view?
No, this is the deck view.
Okay, sorry, sorry about that. Yeah, so this is deck view. So what's on the top deck? Is that only just flat deck? Flat.
Yeah.
Okay. Yeah. I mean, just two consideration. First is on the wave, because the wave in there might be like more than 3 meters, and also on the fuel, on your fuel tank. 30 kilometers, 30 knot, they might not be sufficient to put the fuel in there. But this is only my, I'm just looking, this is only my assumption because you're comparing with the Jumbo 9, which is lower speed and different hull arrangement. It may have a larger fuel tank. Yeah. Okay, I think that's it. Just for my info. If you have any comments on this, just please do.
Yeah. Maybe it's need more time to answer, Mr. Please answer it.
Yes. Yes, from data is web is have BMKG and and 2 meter, 2 meter, 2 meter.
It's all season to make increase.
We use trimmer. Okay. 3 meters. We use 3 meters because that's the rough conditions in the seas. Rough. With Kalimantan seas around 1 until 2 meters wave. Yeah. Uh,
Yep. Maybe for the suggestion for the Historica, you can find the what condition in every month. So you want to respond to the next questions about the security?
Where the tank fuel? Where?
Just go ahead.
Question answer to question 2. Where the consumption fuel oil around 18 until 100 tons one trip for one trip. KM Jumbo over 100 tons. Yeah.
Okay, Mr. Rika, I think it's enough for the questions. Thank you. Prof. Ketut, do you want to ask something? I will give one opportunity to you.
Okay, thank you for the speakers. I agree with Pak Ika, this is a very good idea, but not today. 20 years ago, today when decarbonization is a hot issue, fast craft is not popular anymore because it will consume a lot of oil and then produce more pollution. If we consider other paper that pollution should be reduced significantly. So I wonder if the regulation is strictly applied in Indonesia, maybe this kind of boat cannot be used anymore because of the pollution produced. Or you have to pay tax a lot, yeah, according to carbon tax regulation in the near future. So actually you should consider that. And also, I think there's a regulation in the new capital IKN that private cars should be prohibitive. Won't be allowed only for certain purpose, say for the president, the minister, and so on, and not for rich people, public. So if you build this vessel to bring new cars to IKN, so it won't work. But for bring passengers is okay. Okay, so I think you should consider the current situation. But the rest of that is a good idea. Thank you.
Thank you, Mr. Ika, for the suggestions. I think the time is over limits, so your presentation is already finished in here. Thank you for your presentation, Mr. Arif and Mr. Mikael Arnold. For audience, please give applause to Mr. Arif and Mikael. Okay, we can move to the next presenter. That is Mr. Mahendra Indrayanto, Mr. I Ketut Swastika, and Mr. Taufik Arif Setyanto. The topic is the effect of chamber ratio variation on the hydrodynamic performance of a symmetrical blade propeller. And for the presenter is Mr. Mahendra Indrianto. On the time is yours.
Okay. 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 Assalamualaikum warahmatullahi wabarakatuh. Good afternoon for everyone. Thank you for everyone. Today I will present to our presentation is the topic entitled the effect of chamber ratio variation on the hydrodynamic performance of symmetrical fluid propeller. The chamber ratio can be used a parameter in propeller design. No. Propeller design, improving performance characteristic of the propeller. Today, we learn variation chamber ratio can affect the hydrodynamic performance of this propeller. Okay, next. Ratio is which defined as the ratio of maximum chamber to chord length and the propeller blade foil. Changing the chamber ratio on the propeller foil will change the value of the thrust and torque of the propeller. So the aim of this research is to improve to performance of the symmetrical blade propeller by changing foil chamber ratio is on the propeller blade. The symmetrical blade propeller have been widely on the fast boat on type symmetrical blade propeller is the Count Burrell series. There are several studies in increasing the performance Count Burrell series propeller, but research increasing the performance of convolutional series propeller stroke variation and chamber ratio has not been done previously. Okay, next. On the analysis of the impact and modification of the propeller foil chamber ratio using the CFD method is an effective approach and understand change in fluid behavior around a propeller. By using this CFD simulation, a detailed evaluation of the variation of propeller foil chamber ratio is be carried out, and some calculation result that we approach data from the simulation coefficient thrust, coefficient torque, and efficiency of the propeller. Okay, next. The geometrical modeling of symmetrical propeller. The stress of propeller of CFD simulation based on the model has been created at scale 1 to 16.03. So the model says propeller simulation can be seen the following the table, this table 1 when dimension of propeller. Yeah. The CFD simulation are carried out from the selected propeller models, can reduction of the number of propeller grid element of simulation, reduce time, and can help overcome limitation of available computing resources. Okay, next. This is a picture illustrates the chamber ratio. This study improved the symmetry of the propeller is done by changing the chamber ratio of propeller while with the ratio chamber cut length. The comparison presentation can be seen following the table below. The chamber ratio she will have and the cut length sheet. This is a variation to be 0%. 0% is original foil or without chamber ratio. 1% and 1.5 and 2.5%. Okay, next. Okay. The computational domain is determined following the guideline given the ITTC. This is the domain size expresses multiplication of the propeller diameter. The center of the propeller is 2D downstream from inlet. The outlet is 60 downstream from the propeller center, and the diameter of cylinder side boundary is 60. Okay, next. Okay, and the boundary condition. The purpose of the setting boundary condition is a propeller simulation using CFD. It describes the real operational condition of the propeller fluid and flow environment. Choosing the right boundary condition during CFD simulation will produce calculated result with the good accuracy. So the boundary conditions are defined as follows. The velocity, pressure, air set for fluid boundary condition at the inlet and cylinder side. At the outlet, the pressure keep and constant and maintaining the value pressure 1 atm. The propeller shaft is set a slip condition and the propeller blade as well function is applied. Okay, next. This is a illustration of the meshing. The meshing is an important step in CFD to determine the quality, sustainability, accuracy, and convergence on the simulation. In this figure mesh show fine mesh arrangement in the region around in the propeller, while a quartz grid in the region far away for the propeller. I'm the grid independent. The purpose of the performing a grid independent test in CFD simulation is to ensure the simulation results are independent of the headers and the grid user. By varying the number increasing finer grid, we can observe whether change grid resolution affect the simulation result. The test is important. The test in the grid independent test is important because it provides confident the test simulation has desired level to accuracy help determine optimal grid size. The result of the grid independent test can be seen in the following table, where the percentage difference in the thrust coefficient less than 2% can be selected for the simulated simulation. The validation. The data obtained from the open water test using 6-volt water flood propeller used validated the CFD simulation result for chamber ratio 0%. It's mean without the chamber ratio or original oil. We use a validation this study. By matching simulation result with open water propeller test data, we can evaluate the performance of the simulation they are performed. Validation also provide confidence in the use of CFD simulation to ensure the model simulation reliability can deep insight into the fluid flow response around the propeller. The average percentage difference between the open water test and CFD simulation compare the tank open water test result is 2.88% for question thrust, 2.97% for question torque, and 1.46% for efficiency. Okay, next. This is open water results. The open water result propulsion were conducted the speed to 20 knot. The propeller rotation at full scale is the 550 fpm, which corresponds to Evans coefficient to J 0.9.
Sorry, Mr. Mahindra, your time is only 2 minutes left. Thank you.
Okay, can be seen table 4 the chamber ratio variation or 1.6 and 2.6% experience significant increase thrust coefficient value, but also followed a significant increase the torque coefficient, resulting an increase in chamber ratio variation have impact the efficiency for value propeller performance. At the Evans coefficient 0.6, the thrust coefficient, torque coefficient, and basically summarize the table. Okay, next. In the figure is pressure distribution on the propeller blade surface at conclusion it at G 0.9 and variation chamber ratio 1%, 1.5%, and 2.5%. Okay. Next. Okay. This is a comparison actual velocity between 0% chamber ratio and 1% chamber ratio. The velocity increased from 5 meters per second for the chamber ratio of the 0% to 6 meters per second for the chamber ratio of 1%, which result in increased the propeller thrust. Okay, next. Okay, the conclusion. The studies CFD simulation to examine the relationship between efficiency ratio of symmetrical blade propeller. The chamber ratio considered in the study is 0%, 1.1%, 1.6%, and 2.5%. The CFD results are validated by using data obtained from open water propeller test. Increase chamber ratio, increase the chamber ratio, increase the thrust and coefficient and torque coefficient. The chamber ratio in 1% gives large efficiency of 1.596, which is the 3.85% larger than with case we 0% chamber ratio or original oil. Okay. Next. Thank you.
Thank you, Mr. Mahindra. I'm directly to the Q&A discussions. Is there any? Pak, the blue t-shirt first.
Okay, thank you for the time and thank you for the presentation about the propeller. And I'm interested in the CFD analysis of the propeller because I used to analyze ship hull, and some of the analysis before talk about ships, and this talks about propeller. So the first thing is about the coefficient that obtained from the analysis. Why is it not shown close to zero, the value of the coefficient? That's the first. And the second is about the configuration of the CFD itself, about the modeling of the turbulence. So what type of turbulence modeling? Maybe you can explain more. Is it same as ship, or is different, special for the propeller? Maybe that's all. Thank you.
Okay, thank you for the question. Good question. Okay. The data performance open water efficiency of open water is close to zero, because the advent coefficient J 1.4, the result of CFD simulation, are not inconsistent. There is evidence by the residual value that to be large with to be 10 square minus 2. However, in the study, we know that the performance point of the propeller at advent coefficient at J 0.9. So that value of J 1.4 can be ignored. Okay, and the second question, the simulation in the study is use Omega Fan Marine based a guide Fan Marine theory use AXM, the explicit accelerated stress model, within the two vehicle equation approach.
Is it enough, sir? Thank you. I will move on to Mr. Rika for.
Okay, thank you.
So, okay, this is interesting because not many people do the research on the, camber modification. Just clarification on this result here. So this KQG diagram, this is from the CFD, yes? This is from the CFD. So there is no thrust and torque breakdown near the small J value, which means there is no cavitation. Is that the case when you compare to the cavitation tunnel in the cavitation tunnel?
No, maybe next cavitation next study.
Next study, okay. So this is not validated against the cavitation tunnel, yeah?
No, cavitation. I validated open water test.
Oh, okay.
No cavitation.
You mean open water test using towing tank?
Yeah, previous study in
Towing tank.
which you open water test propeller fast water boat 6.
In a towing tank, or is it in
towing tank?
In towing tank. Okay. Because so do you expect cavitation will occur in here? Because when you change the camber, you put more pressure, which means that you will drop pressure in it, meaning that there will be cavitation. So then if you modify the camber, then it might be also a good idea to see if there is any thrust breakdown in that, because the efficiency might be canceled out by the cavitation on the higher load. Do you expect that cavitation will happen?
Yes.
Okay.
Thank you, Mr. Ika, for your questions. I think that is one question from online chats. Why does G equal 0.9? And better choose minimal 3 of the value of C.
Okay. Point the performance propeller. The after water propeller conducted the speed in the 20x knot, and the propeller rotation full scale is the 160 RPM, and the calculate for G is equal 0.9. So choosing the discussion the point 0.9, not the apa G.
The another G.
Another G.
Okay. Is Miss Tian Purnamasari? Is any response for answer from Mr. Mahindra? Okay, I think. Yeah. Yeah.
Yes. Yes. Thank you for your support. Okay. Yeah. Thank you for advice. Yeah. Thank you for advice. Thank you for advice. Yeah.
Thank you, Mr. Mahindra, for your presentation. For audience, please give applause to Mr. Mahindra for the presentation. Okay, we can move to the next presenter. That is Mr. Z. Aksal and A. Marasa Besi with the title of The Feasibility Study, Technical and Economical of Installation Closed Loop Scrubber on Exhaust Gas System of a Tanker Ships. For Mr. Z. Zaksal, yeah, the time is yours. Okay, Mr. Zaksal, I want to remind you that you only have 10 minutes for the presentation. Thank you.
All right, thank you, Mr. Fatin. Assalamualaikum warahmatullahi wabarakatuh. Shalom, Om Swastiastu, Nama Budaya, Salam Kebajikan untuk kita semua. Good afternoon, ladies and gentlemen. It's a great honor for me to be here in the 8th International Conference on Ship and Offshore Technology Conference. First, our team. The first author is Mr. Resident Aksal Nur Akbar. Our second author is Engineer Amir Marasa Besi. And myself is Audrey Santoso as the third author. So our paper is talking about feasibility study, technical and economics of installation scrub on exhaust gas system. Okay, let's take a look. Next. Okay, this is our outline of presentation. It's first is introduction, and then literature review, and then methodology, and a result discussion, and then a conclusion. Next. Okay, introducing about our topic is marine transportation sector emission contribute 3% of greenhouse gas emission by Humphrey et al. In 2013. And because of that, International Maritime Organization Global Sulfur Cap 2020 declared that mandatory use of fuel with less than. Because of that, our Indonesian ministry declared to a circular with a circular letter of the Directorate General of Sea Transportation, letter number 35 of 2019, at point 2A and point 2C. That declares is Indonesian flag vessels that still use fuel with a sulfur content greater than 0.5% to be equipped with an exhaust gas cleaning system, which is a scrubber with a type approved by the Director General of Sea Transportation. As we know, air pollution in Indonesia or in the world cause discomfort, illness, and health problems, and even death for humans. So this topic is an emergency that we're facing in this world. Next. All right, according to the American Bureau of Shipping, the use of scrubbers is one of the solutions to reduce SOx or sodium oxide content in exhaust gas. By retrofitting the ship machinery with a scrubber system and an exhaust gas cleaning system that will reduce the sulfur content from 3.5% to 0.5%, comply with IMO Sulfur Cap 2020 regulation. Next. Okay, this is our literature review about the scrubbers. The scrubbers are an additional technology tool that can reduce peroxide level in ship engine exhaust gas to a certain extent. What scrubbers are specified at the open loop with scrubbers? On this research, we just use the closed loop scrubber. It's a freshwater system with freshwater is added to a chemical alkali such as caustic soda, and then use as neutralizer when used the flue gas. The used freshwater is recirculated, and any freshwater that evaporates is replaced with additional freshwater. The freshwater that has been used is then treated and reused, while the waste is disposed of. Next. Okay, this is the literature review about ship emission gas. Currently, the heavy fuel oil, or HFO, used by most ships contains 3.5% sulfur. In research conducted by Ibrahim 2016, on fuels that have a sulfur content of 3.5% will produce 900 ppm SO2 in the exhaust gas produced by ship engines. The following is the percentage of exhaust gas content produced by fuel with sulfur content of 3.5%. And the website is HSFO gas emission without scrubbers with SO2 point is 3.5%. And the HSFO gas emission with the scrubbers, it's only 0.02%. That's a huge gap. Next. And then this is our total review for design and closed loop scrubber system. We have to know this requirement data. Include the ship exhaust gas operational requirement data, ship fuel consumption, chemical reaction in the scrubber, heat transfer of closed loop scrubber system, pump and pipe requirements. Next. Okay, this is our methodology. First is information and statement of the problem, literature study and the data collection, scrubber system arrangement design, the analysis of account feasibility methods, this conclusion. There's the two scheme in here. In the left side is scheme with the technical methodology. Start with identification and statement of the problem. And we have a result A. It include the process flow diagram, scrubber equipment calculation, and scrubber system arrangement design. And we move to the left side scheme. It's result A. We're calculating economic cost of capital expenditure or CAPEX and operational expenditure scrubber, and we analyze of economic feasibility methods. Next, we move to the research. This is our requirement data. On the left side is ship particular. The type of vessel is tanker with LOA 225.81 meters, and there's another ship particular data is voyage data, with ship route is from Tanjung Sengkong, Indonesia, to go to the Singapura, to go Fujairah, Arab, and go to the Tanjung Sengkong, Indonesia. With speed is 16 knots. With a round trip per day is 25 days at the sea, and over the year is 10 trips. With the main engine specification, we use the Hyundai MAN BMW. With the fuel specification, we compare the two type of specification, oil specification. That LSFO price point is $543.5, and HSFO price is $398.5. Next. Okay, this is our result and analysis for oil consumption. The left side is fuel oil cost in low sulfur fuel oil. with consumption per day is 51.84, with cost per year is 108 billion rupiah. And the right side is full oil cost with heavy sulfur for the consumption per day is 46.71 ton, and cost per year is only 71 billion rupiah. Next. Okay, after we know the fuel oil consumption and requirement data, we have to analyze the component of the scrubber system. Based on the technical calculation related to the installation process of the closed loop scrubber system, the components have been calculated can be selected according to the needs available in the industry. Selected components such as pumps, pipes, heat exchanger, and wastewater treatment. In this table, we have 6 equipment that SOX scrubber and OH pump, freshwater pump, seawater pump, exchanger, and wastewater treatment. Next. Okay, after we have all the data, we designing the scrubber system. The first thing to do is to describe the process flow diagram, or PFD. This PFD aims to find out the process that are faced in a system, where the system uses a closed loop scrubber system that use fresh water, several additional components that are not owned by scrubber system that use seawater. Okay, sorry for the size of the drawing. In the left side, we have the process flow diagram scrubber. And in the right side, we have closed loop system planning on the ship, tanker ship. Okay, this is the engine room. Okay, the flow of scrubber is start in here, NaO OH pump that flow the NaO into the scrubbers, along to extend tank of fresh water is flow it into the scrubber, and the freshwater pump is flow it to the scrubber. So, and it mixes the NaOH and water, so it reduces the sulfur in the scrubbers. After that, the mixed water and the scrubbers, it's flow to the wastewater treatment to reduce the sulfur and come to the sludge. The water that can be used again come to the freshwater tank. After that, the cycle is going like that again, but in the freshwater tank, come to the scrubber, it's flow into the heat exchanger first to cooling down the water. Next. Okay, this is our result and analysis.
Sorry, Mr. Audi, your time is only 1 minute left.
Okay,
You can.
our total expenditure with the total capital expenditure is 51 billion rupiah. Next. And we have operational expenditure of methodology of economically is 5 billion rupiah. Next. And we can compare the LSFO and HSFO fuel with scrubber, with the original cost in LSFO reached 108 billion, but in the HSFO only reached 76 billion. There's a huge gap. There is a 29% reduction in ship operating costs by using scrubbers to be more efficient than previous operating costs using LSFO fuel. Next. This is our analysis of investment possibility that contain the net present value over the year is 147 billion rupiah, with the internal rate of return is 56.21%, and with payback period is 1.9 years. Next. Okay, this is our conclusion. With first conclusion is technically installing a closed loop scrubber system on a ship requires several components. We can read in here, and
okay, Mr. Audi, I think it's enough for the conclusion.
Okay,
we can move to the sharing Q&A discussions. So I will give opportunity to the audience. Okay, sorry, Mr. Rika, student first to then the girl and the boy.
Okay, thank you. I am Happy Nabila, student in 3rd semester. My question, is there any molecule that can be reduced with the scrubber or only the SOX?
Okay, thank you for the question. that scrubber, your question is if that only the SOX only the reduce for the scrubbers. No, in the previous slide, I mentioned that another component molecule is reduced too, but not effective as effectively as SOX. Okay, is that answering your question?
Yes, thank you.
Thank you.
Okay, next. Okay, thank you. Great presentation for you, Mr. Audi. I have a question for you. Can the slide to the literature review? Literature review. The initial slide. Next, and the other one before. Next. Nah, yeah. Okay. In here, you explain the closed loop scrubber is. Wait. You explain that reduce and clean flue gas by using the fresh water for treat and reuse. At this moment, when you use the fresh water for clean the flue gas, the ship already on the road when the middle of the ocean, you're not worried about the fresh water needed in the middle of ocean because on the ship particular data, the route is so far. I think it's one trip or like you to the port, you filled up the fresh water again or just one trip?
Thank you for the question. Yes, we do fill up in the port. In the Pujaria, we filled up the freshwater tank. But in first trip is that we have a calculation and we have a regulation from American Bureau of Shipping that we have to if we use the scrubber we have to put the freshwater tank into with big 200 meter cubic and we have the expand tank too to fill up the freshwater.
Oh, okay. So you fill up the fresh water and all of the need for the shipping.
Yeah.
Okay. Thank you, Mr. Okay, we have still 10 minutes. I go to Mr. E.
Thank you for the opportunity.
Next questions. Okay, Prof. Ika first. Hey, Ika first.
Okay, thanks. Okay, this is very interesting. I like this. I like this presentation because you provide with the costing comparison, so that gives some idea. What is the which one is better or not. Can we go back to the comparison between LSFO and HFO plus scrubber? There is a comparisons of the operational cost. No, I think what was that one. Yeah. Okay. Now, LSFO is higher than compared to HSFO plus scrubber. So two questions. One is, if I use VLSFO, do I need scrubber or not? This is LSFO, yes. If I use VLSFO, do you think we still need scrubber?
I think
sorry, Mr. Interview, your behind is fast, so please carefully.
Be careful, yeah. Safety first, yes.
We don't have to use it because the LSFO one is, if you want to, you can use it, but for my suggestion is we don't have to do it because the scrubber is for the SOX. So if
the question is that if I choose my fuel from LSFO into very low sulfur fuel oil, which is VLSFO, what is the SOX emission? Is it do I still need scrubber? I'm just curious because I don't know what is the emission level of VLSFO.
This is the first time I hearing too about VLSFO.
Okay. Yeah.
But I think we don't need the scrubber because LSFO means the SOx levels is increased down 0.5%.
Yeah, okay. Okay. Second question.
All right.
Because based on the government regulation, there is a limitation on the sulfur emission, but we do not have yet regulation on the CO2 emission, which is the IMO regulation. When you put scrubber, the sulfur will be drastically reduced, but I can see that the CO2 is not reduced that much, isn't it? Yeah, that's the true, isn't it?
Yes, it's true.
So when you use HSFO plus scrubber compared to LSFO, which one has more CO2 emission?
I have the previous slide that tell us about it's still the same for CO2.
Yeah.
Maybe in the next the future for innovate the scrubber for the CO2.
Yeah, but from your feeling, is it going to be, which one is going to be higher, CO2 emission? Is it HSFO with scrubber or is it LSFO? Which one will produce more CO2 from your feeling, from your gut feeling?
What I'm feeling
Yes.
HSFO with scrubber.
HSFO with scrubber. Yeah. Okay. I think because that's you should put that into your consideration for your next stage, because what happened is that in 2024 there will be limit for CO2 that can be emitted. So then this cost will be much higher because operator will need to pay carbon tax and all that. Yeah. But yeah, it is good overall because there is a money involved in here. This is very good. Yeah. Thank you.
Thank you, Mr.
Thank you,
Rika.
Mr. Rika.
Maybe we have still 2 minutes. I will give a chance to the audience if there is some questions. No. Okay. One more.
Okay, thank you for the opportunity. The question is there an issue about stability after adding scrubber in the funnel and the structure of the ship? Thank you.
Thank you for the question. Your question is about stability of the ship. Okay. Unfortunately, we don't research about the stability. I think my hypothesis about adding the scrubber is affect the stability of the ship, but I don't know exactly how much and how it can be. It's answering your question.
Yes, thank you.
Thank you.
Okay, I think it's enough for the Mr. Zaksan, Mr. Audi, right?
Yeah.
Sorry. Please give applause to Mr. Audi for the presentation. Thank you, Mr. Audi. Please show.
Thank you, Mr. Fatim.
We go to the last presentation in this event. So I would like to say Mr. Iqbal and Mrs. Sulistiawati and Mr. P.G. Suranto with the title is Characteristic of Ship Motion in the Use of Dual Foil NACA 0012 on monohull and pentamaran using CFD simulation. For the presenter, Mr. Iqbal, please come here.
Assalamualaikum warahmatullahi wabarakatuh. It's an honor, everyone, for me to be here. I am Krishna Firmansa. I am third semester. I am as Naval Architecture student. I am here to present characteristic of ship motion in the use of dual foil NACA 0012 on monohull and Pentamaran using CPFD simulation. This is our outline. One is introduced and literature, research methodology, analysis data, conclusion. And our introduce is indicate the multi-hull ships have better compared to monohull ship. This research suggests that the use of dual foil can influence the ship motion performance, leading to a decrease in and its motion. Petamaran is a type of ship with hull used than one, often referred to as multi-hull. The hull arrangement of a pentamaran is similar to that of a trimaran, with a central main and two pairs of side hull on each side. Knowing JD can be configured with a combination of transfer and longitudinal position. Hydrofoil is a fan-like structure designed to reduce a ship resistance, and it is a speed hydrofoil have a structure similar to an aircraft foil. When the ship the water flow generate lift force due to difference in water flow. Dual foil is a dual mounted foil system. The response amplitude operator or RAO is defined as the ratio of the ship motion amplitude, translation, and rotation to the amplitude of a specific frequency. In general, the wave arrival angle is divided into following Cs: quarter Cs, oblique Cs, bow Cs, beam Cs, and head Cs. On movement along the X, Y, and Z axis. When a ship is 6 degrees of freedom or oscillatory motion, this movement are divided into two categories: translation and rotational. In conducting this research, the journal uses a reference is Dr. Wiwin Sulistyawati et al. And missile thin ship theory in optimization of war scene on Pentamaran configuration 2019, and this journal serves as the fundamental model for shaping the whole design of Pentamaran and monohull ship. The modeling of NACA 0012 is based on the journal and Nicholas Charles Townsend. What speed prediction a free running wave propeller boat. Variation in the distance and height of the dual foil on monohull is a model monohull This LX axis and LY axis is M1 to C, 1C and M2 to C and 0.7C and M3 to C and 0.5C and recent extent and height of the dual foil on the Pentamaran ship is model Pentamaran. LX axis and LY axis is P1 to C and 1C, P2 is 2C and 0.7C and P3 2C and 0.5C. In methodology is fixable. One, shipment dimension, two, dual foil nacha 0012, and three, wave heading angle variation and beams, and four, monohull and pentamaran hull, and five, water wave frequency and 0.2, 0.4, 0.6, 0.8, 1.4, 1.6. Variable parameter is foil distance variation in L axis and foil height variation in LY axis. The modeling 0012 on both monohull and pentamaran ship model involves using the LCG or longitudinal center of gravity of the ship at the midpoint of the length L axis for the NACA 0012 variation. For the results, this is have motion for module is based on figure. Okay. Highest row value among the three variation is for M3 and the lowest row value is for M1. Figure based on figure 9, the highest row among the best variation is lowest row value is M1, the row value for M1 decrease 0.6% mentioned. In 19 degrees is based on the figure. The highest row value among the three variation for M3 and the lowest value is for 1. The row value is M1 decreased by 0.5% compared to the M2 and decreased 0.53 compared to M3. This is its motion for monohull. Figure 0 degrees is highest row value among the three variation for M3 and the lowest row value is 4.20% compared to the M2 and decrease by 10.7% compared to M3.
Sorry, Mr. Iqbal, your presentation only 1 minute left, so we can move on.
In conclusion, is the installation of NACA 00.12 on monohull and Pentamaran model after the raw value of model. In all three monohull model, the smallest raw value for half motion is exceeded by the M1 model with an average percentage decrease of the 2.2% compared to and 6% compared to M3 for pitch motion. The smallest raw value is 4 in the M1 model with an average percentage decrease of 1.6% compared to M2 and 3.3% compared to M3. In all three Pentamaran model, the smallest raw value for half motion phase by the P1 model with an average percentage decrease with percentage decrease of 1.1% compared to P2 and 2.5% compared to P3. For pitch motion and smallest raw value is point in the P1 model with average percentage decrease of 1 P2 and 0.18% compared to P3. The whole set of the model can influence raw value with the King's model raw value compared to the monohull model. This evident from the percentage decrease in the average 0.24% for half motion and 0.9% for pitch motion compared to the monohull
Okay,
model.
Mr. Iqbal, I'm so sorry to cut your presentation. I think enough for your conclusion. So I will go move to the Q&A. Is there any questions? Okay, Mr. Fahri.
For our presentation. So I would like to start this about the seakeeping, right? You calculate the RAO and so on. But my first question is what software do you use to calculate this software, this research?
This research with Maxroof and ANSYS Aqua.
Okay, so you using ANSYS and Maxroof.
Yeah.
So to the next question, if you use ANSYS, so I expect there's will be a boundary condition, but I don't see boundary condition in your presentation. Could you explain it to me? What kind of boundary condition that you use in your research?
But I cannot answer this question at this time. Only this presentation. I will review this question in this paper.
Okay, so there is no boundary condition in your research, or there are? Is there boundary condition that you use in your research? Yes, but you cannot. Okay, no problem. Okay, and then I would like to give a comment about this graph. Yeah. So we have like 4 graph, but for the next, it's better for you to using the same parameter. So for example, in 0 degrees, it started from 0 and 1.4. in the y coordinate. And then in 90 degrees, it's from 0 to 30.9. It's not apple to apple. So it's better, it's like a suggestion or recommendation for you to, for the next research, it's better for you to use to show graph which is in the same parameter, either in the y direction or x direction. Okay.
Thank you for clarification.
Okay, thank you, Mr. Fahri. I would like to ask one question for Iqbal. Can you move to the next slide? Before this slide, please. Oh, no. Yeah, I think this one. After next. Yeah. From this slide and the previous one, can you explain what point of you want to deliver to the reader? Because if you look to the these slides and the previous one, there is I not seeing the differences between the point between M1, M2, M3. Can you move the previous one, Mr. Fahri? Can you move to the previous one? Okay, let's see in here, on the P1 and P2, P3 in this table, we can see that the gap is very small. So I want to know what is the point between all of this graph. That is my first question first.
Okay, thank you for the question. Okay. The difference is used to wait.
Or you can, okay, it's okay if you not get to my point, but I have suggestion. In your picture there is, I think there is typo, right? The index. Sorry, Mr. Fahri, Mr. Iqbal, there is some typo, right, for the index P1, P2, P3. Maybe you can fix it to the correct one, because the blue index is P1 and P2. Okay, that's it. That's all from me. Is there any question? Is still 3 minutes left. Okay, because there is no questions, I think we can finish this agenda. Thank you, Mr. Iqbal, for your presentation. Please give the applause to Mr. Iqbal. Thank you all participants. Okay. That's all our agenda in day 2 for parallel sessions. I apologize if I have a lot of mistake to leading these discussions. So so sorry. Assalamualaikum warahmatullahi wabarakatuh. So I want to give the to MC.
Ladies and gentlemen, as we conclude this English Day, I would like to express my sincere gratitude to our esteemed presenter for their enlightened insight. Their expertise has truly illuminated our event. And a special thank you to each one of you in the audience. Your active participation and enthusiasm have made today's discussion engaging and memorable.
Okay, as we bring today's proceeding to a
Everyone, good afternoon, and see you in another occasion.
But before that, to honor participant, please to fill out the survey that listed on the screen, which can be scanned in the barcode. Okay, thank you.